Mr. Clelland here for Clelland Maths. This is your Higher Maths 2025 Ultimate Exam Prep video. Everything in the course, going through topic by topic by topic, including exam questions from 2024 all the way back, going to prep you for your exam. If you like this content and you want to support the channel, consider becoming a member. It is only £4.99, and in return I will be giving you an exclusive live stream lesson the night before the exam. So that's going to be on Sunday the 11th of May at 6 p.m, but you need to join the channel to take part. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code ClellandMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code ClellandMaths. The links are in the description and down below. SQA Higher Maths 2024 Paper 2 Question 1. Triangle ABC has vertices A, B and C with the numbers on them as you can see. You have to find the equation of the median through B. So first glance at this question is, it looks a little bit complicated the way it's drawn, but it's probably going to be okay if we just keep our heads on. So median through B means the line that goes from B and it cuts the opposite line in half. So it's cutting that in half, so I need the midpoint. Let's just call that M, a midpoint of A and C. So I need the mid of AC, so that's minus 3 plus 11 over 2, and it's 8 plus 0 over 2. So let's just work on that. Remember, use a calculator anytime you want. I might not use a calculator much in this paper, but it just depends. So we've got minus 3 plus 11, what does that give me? 11, 10, 9, 8, 8 over 2, and we've got 8 plus 0 over 2, that's 8 over 2. So that's a nice one, that's 4, 4. So there's my midpoint, and now I need my gradient. So I need my gradient between B and M. So gradient between B and M, I've just called it. So B is minus 1, minus 6. So I'll just say 4 minus minus 6 over 4 again, minus minus 1. That gives me 10 over 5, and that's a 2. So my gradient is 2, so y minus b is mx minus a, y minus 4, 2x minus 4, y minus 4 equals 2x minus 8, so y equals 2x minus 8 add 4 is minus 4, and we're done there for part A. Part B says find the equation L, the line perpendicular to BC passing through C. So there is C there, so there we need the gradient of BC, because we're going to use M1, M2 minus 1, and then we'll just use the point C. So for part B, we need the gradient of B and C. So let's just check our points. We've got 0 minus minus 6. And we have 11 minus minus 1. So that is just 6 over 12, which is a half. And therefore, the gradient of the perpendicular is minus 2, because M1, M2 equals minus 1. Always need that little statement. And now we use the point C. C is 11, 0. So we're going to use C, which is 11, 0. So y minus b, that's 0, equals m, x minus 11. So that just gives me y equals minus 2x. A minus times a minus is a plus, plus 22, and we're done there. Part C, determine the coordinates of the point of intersection between the median and the line. So we've got two equations, 2x minus 4, and minus 2x plus 22. So for part C, y equals 2x minus 4, and we've also got y equals minus 2x plus 22. So we can just say that 2x minus 4 is minus 2x plus 22. Taking the 2x over to this side gives me 4x, and taking the minus 4 over to the other side, add 4, 22 plus 4 is 26. X is 26 over 4, which I'll just simplify to 13 over 2. I'll just leave it as a fraction, why not? When x is 13 over 2, I need to find the y. So y equals 2 times 13 over 2, 2x minus 4. So that's 2 divided by 2 is 1, so that's just 13 minus 4 then. 13 minus 4 is 9, so the point of intersection we can say is equal to 13 over 2 for the x and 9 for the y. And we're done there for question 1. Higher Maths 2022, Paper 1, Question 1. Determine the equation of the line perpendicular to 5x plus 2y equals 7, passing through minus 1, 6, perpendicular, which means the gradients multiply together to give minus 1. So for gradient of this line, we've got 2y equals minus 5x plus 7. So y is minus 5 over 2, x plus 7 over 2. The gradient of this line is minus 5 over 2. So the gradient of our perpendicular line is equal to 2/5, since m1 times m2 equals minus 1. 2/5 and minus 5 over 2 gives us 2 marks already. Then we can just do the equation of a straight line. Y minus b equals mx minus a. Minus 1 is plus 1. So 5y minus 6, you might do, is 2x plus 1. Expanding our brackets, we get 5y minus 30 is 2x plus 2. So I'll leave it with 5y is equal to 2x. 2 plus 30 is 32. And you can leave it in any form you want. Y equals mx plus c. A multiples of y equals a multiple of x plus a multiple of a number. Whatever you want, really. So 5y minus 2x equals 32. And you can just leave it like that, or in any other correct form for the equation. SQA Higher Maths 2019, Paper 1, Question 7. The line L makes a 30-degree angle with positive direction of x-axis. Find the equation of a line perpendicular passing through 0, minus 4. Gradient equals tan of 30, which is equal to root 3. 1 over root 3. So that means the gradient of our perpendicular is equal to minus root 3, since m1 times m2 equals minus 1. And then we can just use y minus b, y plus 4 then, equals minus root 3 x minus 0. So y equals minus root 3x minus 4, and we're done there. SQA Higher Maths 2015, Paper 1, Question 9. ABC are points such that AB is parallel to the line with equation y plus root 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Are they collinear? So you need to know what collinear means. They are all in a straight line. So if you work out if A to B are parallel and B to C are parallel, and when it says B is a point in common, they would be in a straight line because they're parallel or not. So let's just work on this. So the first part is to work out the gradient of AB. So for A to B, we have got y equals minus root 3x. So the gradient of that section is just minus root 3. For B to C, well, gradient equals tan theta, because we've got the angle 150 degrees. So our gradient is equal to the tan of 150. Now, 150 is going to be an exact value. If you've got a cast diagram, we can see it's related to 180 minus 150. So if I work out the tan of 30, the tan of 30 degrees is 1 over root 3. But 30 degrees is positive here and here. So that's 180 plus 30, which is 210. And that's 180 minus 30, which is 150. Here, tan is negative, so the tan of 150 is minus 1 over root 3. And then we can just make a little statement. Since the gradient of AB doesn't equal the gradient of BC, the points are not parallel. And so they're not collinear. Not parallel, so not collinear. Now, if they were equal, you would then say they are parallel, but since B is a common point, they're collinear. SQA Higher Maths 2023, Paper 2, Question 1. Triangle PQR has these vertices. Find the equation of the altitude from P. Well, what they're drawn in is a right angle. So if I can find the gradient of QR, I'll know the gradient of the perpendicular. So part A, the gradient of QR. I've got 3 minus 8 on the top over 13 minus 2. Y2 minus Y1 over X2 minus X1. 3 take away 8 is negative 5. 13 minus 2 is 15. That gives me minus a third. And therefore, the gradient of the perpendicular must be 3, since M1 times M2 equals minus 1. And you always need that statement. So now we can use the point P to get the equation. So P is 5 minus 1. So I can use y minus b, y minus 1 equals 3x minus 5. So y plus 1 is 3x minus 15. And therefore y must be 3x minus 16. And we're done there. Part B, calculate the angle beside PR makes for the positive direction of the x-axis. Well, we know that gradient equals tan theta. So we need the gradient of PR. So let's look at P and R. We've got R, 3 minus 1 on the top, over 13 minus 5 on the bottom. That gives me 4 over 8, which is 1/2. So our tan theta equals 1/2. So the inverse tan of 1/2 equals, using a calculator, you get 26.565 or 26.6 degrees. And we're done there. SQA Higher Maths 2024, Paper 1, Question 1. A line passes through the point 0,4, makes an angle of 30 degrees with a positive direction of the x-axis. Determine the equation of the line. Oh, that's nice and simple to start with. Gradient equals tan theta. And it is the positive direction, so it's just tan 30 degrees. And an exact value triangle will help with this. 60 and 30. 2, 1 and root 3. So tan 30 is opposite over adjacent, 1 over root 3. So now I've got the point on the y-axis, so I can just use y equals mx plus c, because I've got c is 4. Mx plus c, so y equals 1 over root 3 x plus 4. And we're done there for question 1. SQA Higher Maths 2023, Paper 1, Question 2. P and Q are points -2, 6 and 10. 0, find the equation of the perpendicular bisector. So if I've got a line, let's say it was here, -2, 6, and 10, 0. Perpendicular means at right angles, bisector means in half. So I'm looking for a line that looks like this, I suppose, where that's at right angles and it cuts it in half. So I'm going to need the midpoint and the gradient of perpendicular. So let's start off with gradient. The gradient of P to Q is y2 minus y1, so that's 0 minus 6, over x2 minus x1, 10 minus 2, that's negative 6 over 12, which is negative 1/2. So that means that the gradient of our perpendicular straight away equals 2, and we need to write since m1 times m2 equals -1. So we've got our gradient is 2, now we need our point, so the midpoint. So the mid of PQ, we add the x's, so we've got 10 minus 2 divided by 2, and the y's, 6 plus 0 divided by 2. That gives us 8 over 2 and 6 over 2, which is equal to 4 and 3. So we've now got our point and we've now got our gradient, so we can use y minus b equals mx minus a. So y minus b equals mx minus a, where that's our a and b, and that's our m. So we've got y minus 3 is 2x minus 4. Y minus 3, 2x minus 8. So y is 2x minus 8 add 3 is minus 5. And there we are. SQA Higher Maths 2017, Paper 2, Question 8 on sequences. This time it has quadratics in it as part of the question. So it says sequences may be generated by the recurrence relationships of the form un plus 1 is k un minus 20 and u0 equals 5, where k is a member of the real numbers. Show that u2 equals this expression. Well, u2 is generated by u1. I've not got u1 or got u0. So first of all, for part A, I need to find u1 because it will be k times u0 minus 20. And we know that u0 equals 5. So we can sum in that to get u1. 5 times k minus 20. And now we can find u2 because going up, u2 is just going to be ku1 minus 20, but we know that u1 is equal to 5k minus 20. So we can just sum that in. So that means that u2 is k times the whole of u1, 5k minus 20, then take away 20 on the end. That gives me 5k squared, multiplying out the bracket, minus 20k, and then we've got minus 20 on the end, as required. Part B, determine the range of variable for which u2 is less than u0. So part B, if u2 is less than u0, then we can just say that 5k squared minus 20k minus 20 is less than u0, which was 5. And we're just solving a quadratic inequality. So now we're moving away from sequences and moving into quadratic inequalities. So let's just do this for the sake of completeness. We've got 5k squared minus 20k, and taking the 5 over, that gives me minus 25 is less than 0. And we can examine the turning points. So if we have to examine the turning points, that is happening when 5k squared minus 20k minus 25 equals 0. Taking 5 out as a common factor, we get k squared minus 4k minus 5 equals 0. And we can factorize as much as we want to get k and k, 5 and 1. And 5, it'll be minus 5 plus 1. So we get turning points when k is equal to minus 1 or k is equal to 5. So looking at the turning point, we can then just draw a quick sketch of a graph, noting minus 1, noting 5. There's your rough graph. And we want 5k squared minus 20k minus 25 to be less than 0. So we're looking at, if I just draw this in a different colour, it's less than 0 when it's below the x-axis. So it's below the x-axis in between these 2 points. So that happens when minus 1 is less than k is less than 5. So when minus 1 is less than k, and which is less than 5, and we're done there. SQA Higher Maths 2024 Paper 1 Question 2. A sequence is defined by a recurrence relationship. un plus 1 is a fifth, un plus 12, and u1 is 20. Calculate the value of u2. Okay, so u2 is a fifth, u1 plus 12, but u1 is 20. So that's a fifth times 20 plus 12. A fifth of 20 is 4. 4 plus 12 then is 16. And we're done there. Part B, I. Why does it approach a limit as n goes to infinity? Because minus 1 is less than a fifth, which is less than 1, therefore the limit exists. Part 2, calculate this limit. Well, I use b over 1 minus a. So that is a and that is b. So that's 12 over 1 minus a fifth. That's 12 over 4 fifths. That's 12 times the reciprocal of 5 quarters. 12 divided by 4 is 3 times 5 equals 15. And we're done there. SQA Higher Maths 2019 Paper 2 Question 4. It says, in a forest, the population of a species of mouse is fallen by 2.7% a year. To increase the population, scientists plan to release 30 mice into the forest at the end of the year. It says UN is the estimated population at the start of April, n years after the population is first estimated, and it knows that UN and UN plus 1 satisfy this recurrence relationship. State the values of A and B. So for part A, it's really about pulling out the information from the question. So let's have a look at this. we have got is falling by 2.7%. So to work out A is going to be the percent times UN, but what's left over? So it's 100% minus 2.7%. That gives me 97.3%. So A is equal to 0.973. And then B, we plan to release 30 mice into the forest at the end of each year, so B is 30. And we're done there. Question B. Explain why the estimated population of mice will stabilise in the long term. So it mentions stabilising, so it means a limit exists. So we can say a limit exists since -1 is less than 0.973, which is less than 1, and that's all we need to say. Step 2, calculate long-term population of nearest 100, and always find the limit. So for part 2, L equals B over 1 minus A. So we'll just plug our numbers in. B is 30, then it's 1 minus 0.973. 30, over 0.027, which is 111.11, 111.11, or to the nearest 100, 1100. And we're done there. SQA Higher Maths 2019, paper 1, question 4. A sequence is generated by UN plus 1 is M, UN plus C, where the first three terms are 6, 9, 11. Find the values of M and C. So we have got 6, 9, and 11. So we could call that the first term, the second term, and the third term. So the second term would equal M times the first term plus C. And the third term would equal M times the second term plus C. So we can just sub them in. So U2 is 9, is equal to 6M plus C. And U3 is 11, that equals 9M plus C. Simultaneous equations to solve. So we can just do 2 take away 1. That gives me an 11 take away 9 is 2 is equal to 3M. So M is 2/3. Sub that in, we get 9 is equal to 2/3 times 6 plus C. 6 2s are 12 divided by 3 is 4. So 9 is equal to 4 plus C, and therefore C is equal to 5. It then says part B, calculate the fourth term of the sequence. So for part B, U4 is equal to M, which is 2/3, times U3, plus C, which is 5. And U3, remember, the third term was 11. So that equals 2/3 of 11 plus 5. So 11 times 2 is 22 over 3. So I might as well make the 5 15 over 3. So we've got a common denominator. 22 plus 15 is 37 over 3. And if that's already simplified, I'll be done. Well, it is simplified, so I'm done. SQA Higher Maths 2015, paper 2, question 3 had this long one. It says a version of the following first appeared in print in 16th century. Who really cares? A frog in a toad foot at the bottom of a well is 50 foot deep. Each day the frog climbs 32 foot, rests overnight. During the night it slides 2/3 of its height above the floor of the well. The toad climbs 13 foot before resting, then it slides 1/4 of its height. So we need to see what this question is asking us, but it gives us two recurrence relationships. It says the progress can be modelled by this. F of n plus 1 is a third f of n plus 32, and the first term is 32. And then for the toad, Tn plus 1 is 3/4 Tn plus 13, with the first term is 13. And it says F and T are the heights reached by the frog and toad at the end of the nth day after falling in. Part A, calculate T2, the height of the toad at the end of the second day, only worth 1 mark. So to calculate T2, you just sub in T1. So let's just go ahead and do that. So for part A, T2 is going to equal 3/4 of T1 plus 13, but we know that T1 equals 13. So therefore we can just say that T2 is equal to 3/4 times 13 plus 13. Nice and simple there. Well, this was a calculator question, so we just do 13 times 3 is 39. Divide that by 4 and add 13, and we get 22.75. Okay, part B of the question says, determine whether or not either of them will eventually escape the well. Now this seems to be like, well, what's this asking me? Whenever a question says, basically, will something happen after a certain amount of time and it's to do with recurrence relationships, it's asking whether it's got a limit or not, okay? So if you understand that when a sequence has a limit, you'll be fine. Now, a sequence has a limit when A, the number in front of here, f of n or t of n in this case, is between minus 1 and 1. So let's just save that. So for part B, if we look at our frog first of all, that is f of n plus 1 is a third f of n plus 32. Let's just write that down. We can say that the limit exists because minus 1 is less than a third is less than 1. So limit exists since minus 1 is less than a third, which is less than 1, and we can calculate that limit. So the limit, remember, is equal to b over 1 minus a, where that's my a and that's my b. So that equals 32 over 1 minus a third. And since it's a calculator question, you can just do that in a calculator, or without a calculator, that's 32 over 2/3. Now I'll just do it without a calculator just to show you how. So L would equal 32 times 3/2. Divide by a fraction times by its reciprocal. 32 divided by 2 is 16. 16 times 3 is 48. So the limit, or in other words, where the frog will reach, will be 48. Now 48, we know the well from the question is 50 feet, and therefore the frog will never reach or escape the well. So therefore the frog will never escape the well as 48 is less than 50. And then we can do the same thing for the toad. So let's look at our toad. His recurrence relationship was Tn plus 1 is 3/4, Tn plus 13. So the limit exists since minus 1 is less than 3/4, which is less than 1, and we can calculate that limit. L equals b over 1 minus a, which is 13 over 1 minus 3/4, which again, you could just use your calculator to work this out, but that is 13 over a quarter. 13 over a quarter is the same as 13 times 4 over 1, so that is 52. So we can then say the toad escapes the well since 52 is bigger than 50. And we're done there. SQA Higher Maths 2019 Paper 2 Question 8 on functions and inverse functions. A function f is given by f of x is a cube root of x plus 8. It tells you the domain is 1 between 1 and 1,000, and it's a real number. If inverse function is this, find the inverse function. So how I always do this is I let y equal the cube root of x plus 8, and I'll just rearrange that to make x the subject. So y minus 8 equals the cube root of x. Cubing both sides then, I get y minus 8 cubed equals x, and I then straight away can just jump in and say that the inverse function of x then is equal to x minus 8 cubed. I just swap the y for an x. Do not write at this point here, this is very important. Do not then write y equals nx there, because you've already said that y equals this, so it doesn't equal that with an x in it. Just jump from here to here and you're done. Part B, state the domain of the inverse function. The domain of the inverse function is the same as the range of the original function, okay? So let's check the range of f of x. So I'll just write it down. Range of f of x equals domain of the inverse function. in becomes out and out becomes in. So what's the range? Well, the range of f of x is just putting in f of 1. Well, that's the cube root of 1 plus 8, which equals 9. And f of 1,000, which is the highest number it can be, is the cube root of 1,000 plus 8. Well, 10 times 10 is 100, times 10 is 1,000, so that's 18. So therefore, the domain of the inverse function is 9 is less than or equal to x is less than or equal to 18. And we're done there. It's between 9 and 18. SQA Higher Maths 2024, paper 2, question 8. Functions f and g are defined on R, the set of real numbers, by 2x squared minus 18 for f of x. G of x is x plus 1. Find an expression for f of g of x. F of g of x, you usually get a mark for substitution. So it's 2 g of x squared minus 18, just to show that. G of x is x plus 1. So you just go straight to this step if you want, minus 18. Now I think you'll get all the marks for that. You don't need to do anything else. And the way I've solved this, it's handy to have it like that. But in case anyone did multiply it out, I'll multiply it out. 2 x squared plus 2x plus 1 minus 18. So that gives me 2x squared. 2 2's is 4x. 2 1's is 2, but 2 minus 18 is minus 16. So either of them should be fine. Question B says, find the values of x so that 1 over f of g of x is undefined. Well, that means that you can't have that bottom bit being 0. So that means that you could say that f of g of x cannot equal 0. So I want to find the numbers which make that happen. So I'll just make it equal to 0 and see what I get. So you've got 2x squared plus 4x minus 16 equals 0. But notice at the start, that was in completed square form. So you can start from that point and probably solve it a lot quicker. Or you can start from this point. Since I'm here now, I'll just do that anyway. So I've got 2 bracket x squared plus 2x, and I've got minus 8 equals 0. So that's 2 double brackets. Let's hope it actually factorises in if we're doing it this way, because I would do it another way. I think it's going to be 4 and 2, is it? Okay. And I want plus 4 minus 2. Okay. So I've got x equals 2, x equals minus 4. So you just say undefined when x equals 2 or x equals minus 4. Find the values of x, so it's undefined. Undefined when? You could actually answer the question by saying that if you wanted to say what the range is, you could say that x is a member of R and x cannot equal minus 4 and x cannot equal 2. But really, we're saying what values for x is this undefined. So if it's undefined when x is equal to 2 and x equals minus 4 is actually the answer. Now, going back up, if you'd done it from completed square form, just as a kind of side note this, 2x plus 1 squared minus 18, this is the power of completing a square. That means that I can take the 18 over, 2x plus 1 squared equals 18. And that means that x plus 1 squared equals 18 over 2 is 9. I can just square root both sides. That gives me x plus 1 equals plus or minus 3. So x equals, when it's plus 3, 3 minus 1 is 2. And when it's minus 3 minus 1 is minus 4. And you would get the same thing. And there we are. 5 functions f and g are given by f of x is x squared minus 2, g of x is 3x plus 5, with defined expressions for f of g of x and g of f of x. And then determine the range of values for which f of g of x is less than g of f of x. Let's get straight into it. Part 1, f of g of x equals, so we've got f of x is x squared minus 2, so we've got g of x squared minus 2, and g of x is 3x plus 5. 3x plus 5 all squared, take away 2. 3 3's are 9x squared, 3 5's is 15, times 2 is 30x. 5 5's is 25, minus 2. So f of g of x equals 9x squared plus 30x plus 23. Part 2, g of f of x. Well, g, I remember, is 3x plus 5, so it's 3f of x plus 5. That's 3 times x squared minus 2 plus 5. So g of f of x is 3x squared minus 6 plus 5. G of f of x, 3x squared minus 1. Determine the range of values for which f of g of x is less than g of f of x. So we're saying f of g is less than g of f. So x squared plus 30x plus 23 has to be less than 3x squared take away 1. Taking the x squareds across, we've got 6x squared plus 30x plus 23 is less than minus 1. So 6x squared plus 30x plus 24 is less than 0. So we've got a quadratic inequality to solve. So let's look for a common factor. 6x squared plus 5x plus 4 is less than 0. So let's look at the roots of x squared plus 5x plus 4. So that factorises to give us x and x. We've got 4 and 1, plus and plus, so roots at x equal minus 1, x equal minus 4. So we can draw a quick graph to show the roots. Minus 1, minus 4. Less than 0 means below the x-axis. Under here, well, it's under here when it's between these two numbers. So our final answer, minus 4, is less than x, which is less than minus 1. SQA Higher Maths 2023, paper 1, question 13. Two functions f and g are defined as f of x is 2 sine x for between 0 and pi over 2, and g of x is 2x for between 0 and pi over 4. Evaluate f of g of pi over 6, and then find an expression for f of g over x. So we might as well do the first one direct instead of going f of g of x first, but you could have done that first and then subbed it in. So for part 1, I want f of g of pi over 6. Well, g of pi over 6 is simply 2 times pi over 6, because g of x is 2x. That is pi over 3. So f of g of pi over 6 is just simply f of pi over 3. F is 2 sine x, so it's 2 times the sine of pi over 3. So the sine of pi over 3 is an exact value. If you don't know it, pi over 3 is 60 degrees, so I've got 60 degrees here. I've got, I think, equilateral triangle, so it goes 2, but it's been cut in half 1, and that's root 3. So the sine of pi over 3, opposite over hypotenuse, is root 3 over 2. So that's 2 times root 3 over 2, which is just simply root 3 as our final answer. Part 2, determine an expression for f of g of x. So f of g of x is equal to f of, well, g of x is 2x. So that is 2 sine 2x. 2 sine 2x. And we're done there. Part B, given that f of p is a third, determine the exact value of sine p. So f of p, part B1, f of p is just going to substitute p in, 2 sine p. But it's told us in the question that f of p equals 1/3, and therefore sine p is equal to 1/3 divided by 2, which is 1/6. Part 2, hence determine the exact value of f of g of p. So B part 2, f of g of p. Well, f of g of x is 2 sine 2x, so f of g of p is 2 sine just change it to a p. So 2 sine 2p, well sine 2p is 2 sine p cos p from the start of the exam paper. So it's 2 times 2 sine p cos p, which is 4 times sine p cos p. Now I already know sine p is a sixth. So if sine p is a sixth, if I draw a little right angled triangle and call that p, opposites 1, hypotenuse is 6. So I can do Pythagoras. 6 squared minus 1 squared, 36 minus 1 is 35, so that side is the square root of 35. So this gives us 4 times the sine of p, which is a sixth, times the cos of p, which is going to be adjacent of hypotenuse, which is root 35 over 6. You may be wondering, is root 35 a simplified third? Well, 4 doesn't go into 8, 9 doesn't go into 8, 16 doesn't go into 8, 25 doesn't go into 8. So no, it's already simplified. So when we just times the top, 4 root 35, times the bottom, 36. Simplify the 4 and 36 to get root 35, 4 9s are 36. Doesn't look simplified, but it actually is. There's nothing else you can do with that, so we're done. SQA Higher Maths 2024, paper 1, question 5. Function h is defined as h of x is 2x cubed minus 7. Find the inverse function h minus 1x. So I'll just start with y equals 2x cubed minus 7. Make x a subject. Y plus 7 is 2x cubed. Y plus 7 over 2 is x cubed then. So y plus 7 over 2 cube rooted equals x. But don't switch them back. So you just now straight away go into the inverse function of x equals now switch back. Cube root x plus 7 over 2, and we're done there. SQA Higher Maths 2023, paper 2, question 6. A function f is defined as f of x equals 2 over x plus 3 for x greater than 0. Find the inverse function. So what I usually do with these is I write y equals 2 over x plus 3. Well, there's other ways to do these. And make x the subject. So taking away 3, I get 2 over x. Multiplying each side by x, I get x bracket y minus 3 equals 2. And dividing through by y minus 3, I get x equals 2 over y minus 3. So then I immediately write down my answer. The inverse function of x is equal to 2 over, now just x minus 3. Make sure you do not write at any point swapping these back to y and x, because then you'll get an inconsistent answer and you'll lose a mark. Inverse functions, SQA Higher Maths 2016, paper 1, question 6. F and g are defined in the real set of numbers and the inverse functions both exist. Part A, if f of x is 4x plus 5, then the inverse function of x. So for part A, I can just write y equals 3x plus 5 and make x the subject. So that means that y minus 5 equals 3x. And therefore y minus 5 over 3 equals x. Don't now be tempted to write y equals x minus 5 over 3 or you'll lose a mark. Just go straight into therefore the inverse function of x equals y becomes x, so x minus 5 over 3. And we're done there. Part B of g of 2 equals 7. What is the inverse function of g of 7? Right, that sounds a bit strange, but this relies on you knowing what this means. If I put in 2 and I get 7, then that means that if I put in 7 in the inverse, that takes me back to 2. So that just means the inverse of 7 is just 2. There we go. SQA Higher Maths 2019, paper 1, question 10, graphs of related functions. The diagram shows the graphs of f of x and kf of x plus a. We'll have to find the values of a and k. So where's our f of x? It's this one here. And kf of x is the other one, plus a. So that's flipped upside down. And then it's maybe moved up or down. So to work out a, first of all, just compare it on this bit here. That's 0, 0. And that's 0, 3, it's clearly moved up by 3. Even if it's flipped upside down, it's still moved up by 3. So a is equal to 3. So we can just write down 3 straight away, no problem there. Now we need to find our k. Well, we know it's flipped upside down, so we know straight away it's negative. And how much? Well, just imagine if you flip this graph upside down, then you will be kind of drawn it like this. So this point here, 2 minus 1, will become 2, 1. So let me just take a note of that. That would kind of go up and become 2, 1 when it's upside down. But then we move up to 5. Now, even if I add 3, I don't get 5. So 2 times 1 is 2, plus 3 is 5. So that means k is minus 2. And we're done there. SQA Higher Maths 2024, Paper 2, Question 4. The diagram shows the graph of a quartic function. Wow. The maximum turning point occurs at minus 1, 3. The graph of y equals f of x has a point of inflection at x equals 2. And always a turning point that doesn't turn, keeps going down. And determine the coordinates of the maximum turning point of the graph of y equals f of x minus 4 plus 2. Well, the turning point to start with is minus 1, 3. So we're starting with minus 1, 3. Now this bit here, the bit that says x minus 4 means a shift to the right by 4. So I'm going to go right by 4. And then the bit at the end, plus 2, up by 2. So that becomes minus 1 shifts to the right. Minus 1 add 4. That gives me 3. 3 goes up by 2. That gives me 5. 3, 5. Job done. Part B. In the diagram in your answer book, sketch a graph of the derivative y equals f dash x. So I've got a method for this, and this is my method that I use. I do this as if I'm doing a nature table basically, and I'm going to say that's my derivative, and I'm going along to the turning points because the turning points on the graph of the derivative turn into roots because the 0 gradient. So the first turning point is minus 1, and then we go along and we get another turning point at 2. And then we go along, and then we just examine what happens before and after this turning point. So checking my graph, I'm going up the way, so that's positive. Then I'm going down, that's negative. And then I'm going down again, that's negative. So it's positive, negative, negative. So I can just write that. So the first one is positive, that's 0, negative, that's 0, and negative. So in terms of thinking about where I'm drawing this, I'm drawing that above the x-axis, on it, below it, on again, and then below. So then what you do is you get your diagram. Now I've not got one because I've not got an answer book yet because I'm not a student. So I'll just draw it by hand. X and Y. You put your turning points on as your roots. Minus 1. Let's just call that 2. And I'm thinking I'm above before minus 1. So I'll just put a wee mark just to remind me. And then I'm below after minus 1. And then I stay below. And then I need to go back up here. And then go down a low. So that must be a turning point that I just touch and hug. So we can just kind of think of this as we're going to go down, we need to go up at some point, and then we're going to go back down. So that looks like a decent graph, and we're done there. Solving logarithmic equations, SQA Higher Maths 2018, Paper 1, Question 11. Diagram shows log 3x. On the diagram in the answer book, sketch the curve of equation 1 minus log 3x, and then find the point of intersection between the curves, which will be solved for the logarithmic equations. So 1 minus log 3x, the minus part here tells me to reflect in the x-axis, and then the 1 part, which I'll do in another colour here, tells me to then move up by 1. So first of all, reflecting in the x-axis, this point will stay where it is, but this point will jump down here, and that would be at the moment as in point 3 minus 1. But now I have to move up by 1, so this point is going to jump up by 1, so that becomes 1, 1. And you can see this point goes up to 3, 0. So I can just write the number 3 here. Getting rid of my intermediate working, which you could use a rubber if you were doing this by hand. And since it's reflected, it's going to go down and through here. So we can just draw that in, down here, through the way, and there we go. It's a reflection in the x-axis. Okay, part B, determine the exact value of the point of intersection, simultaneous equations. So for part B, we've got y equals log 3x, but we've also got y equals 1 minus log 3x. So we can say that they are equal to each other and find x. So log 3x equals 1 minus log 3x. So taking the log 3x to the other side, you'll have log 3x plus log 3x. So 2 of them, 2 log 3x equals 1. I can take the 2 up as a power, so I get log 3x squared equals 1. Now I've got it in the form log of something equals a number, so 3 to the power of 1 equals x squared. 3 to the power of 1 equals x squared, and therefore I can find x. X equals 3 to the power of a half, or x equals the square root of 3. And we're done there. Notice it'll only be the positive part of this instead of the negative part, because if x was negative, then you would have log of a negative number, which doesn't exist, so it's just a positive. I can take a note of that. Just positive value, as x has to be greater than 0. SQA 2022 Higher Maths Paper 1, Question 7. Triangles ABC and ADE are both right angles. It tells us that angle BAC equals Q and DAE equals R. As shown in the diagram, calculate sin R, sin Q. So we can pull some information out of this diagram by drawing some triangles. So let me draw the small one first. If I do a little sketch, we've got R here. This whole length here is 3, and the whole length on the top is 1. So by Pythagoras, 3 squared plus 1 squared equals 10. So that must be the square root of 10. We can do the same for the Q triangle. If I just do that at the side, if I call this Q, then on the hypotenuse we've got root 13, and on the bottom we've got 2. So by Pythagoras, root 13 squared minus 2 squared is 13 minus 4, which is 9. So square root of 9 is 3. So nice and simple then. Determine the value of sin R. Sin R, opposite of the hypotenuse, is 1 over root 10. And sin Q, opposite of the hypotenuse, is 3 over root 13. 2 marks there. 1, 2. Nothing else you're going to do there. So let's go to part B. Okay, here's determine the value of sin Q minus R. Sin Q minus R equals sin Q cos R minus cos Q sin R. From the start of the exam paper, you'll get that. So we need to work out our different things. So sin Q is 3 over root 13. Well, cos R, well, we've already got our triangle here, so 3 over root 10. And minus cos Q, which using this triangle is 2 over root 13. And we've got sin R, which we already know is 1 over root 10. Times in the tops of them, we get 9 over root 130 minus 2 over root 130, which is obviously 7 over square root of 130. Always double check if you can simplify that third at the end, but you can't, and you don't have to rationalise the denominator for the marks because we're not examining that. So where do you get your marks for part B? If you wrote down sin Q cos R minus cos Q sin R, or you imply that by doing this, you get your marks. So there's mark 1 and 2. Substituting in 3 over root 13, 3 over root 10 minus 2 over root 13 times 1 over root 10 is your second mark, and then your final mark, obviously, for working it out as 7 over root 130. So there's your final mark there. SQA Higher Maths 2024 Paper 1, Question 6. A right angle triangle in the diagram is such that sin P is 1 over root 5, P is between 0 and pi over 4. Then the value of sin 2p, cos 2p, and then sin 4p. So I've got a right angle triangle, so I will do Pythagoras to get one of the sides. So I've got root 5 squared minus 1 squared. That's 5 minus 1 is 4. So I've got root 4 is 2. So now expanding this, that's 2 sin p cos p. So what's cos p? Cos p is opposite, adjacent of hypotenuse, 2 over root 5. And we already know sine p is 1 over root 5. So that's 2 times 1 over root 5 times 2 over root 5 times in the top, 2 times 1 times 2 is 4, times in the bottom, root 5 times root 5 is just 5. So you get 4/5. Cos 2p, well again, using the start exam paper, you can use any of the expansions you want, and the one I'm choosing to use is 2 cos squared p minus 1. But you'll get the same answer, I'm just using that because it's got a positive value. So that's 2, cos p is 2 over root 5, so I need to square that and then take away 1. So that's 2 times 2 2s is 4, root 5 times root 5 is 5, minus 1. 2 4s is 8 over 5, minus 1, which is 5 over 5. That gives me 3 over 5, and we're done there. Hence, determine the value of sine 4p. Now, sine 4p is like sine 2p. If sine 2p is 2 sine p cos p, then this will be sine 2p cos 2p instead of pp, because it's 4p instead of 2p. So then I can just substitute in 2 sine 2p. Well, I know sine 2p is 4/5, so I can just write 4/5. And I know cos 2p is 3/5, so I can just write 3/5. So that gives me 2 4s is 8, 8 3s is 24, over 5 5s is 25. And we're done there. Higher Maths 2015, Paper 1, Question 10, Addition and Double Angle Formulae. Given that tan 2x is 3/4, part A, find cos 2x. Right, okay, so part A, we know tan 2x is equal to 3/4. So that means we can draw a right angle triangle, and we could call this angle 2x. And opposite is 3 and adjacent is 4. By Pythagoras, 3 squared plus 4 squared is 5 squared. This is a standard Pythagorean triple. So we can immediately write down cos 2x because that is adjacent over hypotenuse, which is 4/5. So a simple 1 mark question there. Part B, we have to work out cos x. Well, we can't go from cos 2x to cos x directly. Don't be tempted to divide by 2. We need to expand cos 2x. So there's the start of the exam paper. There's a number of trigonometric identities. Pick the one you want. 2 cos squared x minus 1 would work. So I'm going to pick 2 cos squared x minus 1. And cos squared x is the same as cos x squared, remember. So we know cos 2x is 4/5, so we've set up an equation basically, because that equals 4/5. So that means that I can add 1 to both sides to get 2 cos squared x. Well, if I add 1, it's the same as adding 5/5, so 5 and 4 is 9. That gives me 9/5. So cos squared x dividing through by 2 is 9 over 10. And therefore cos x is the square root of 9/10. So I can write that down. Cos x is the square root of 9/10. Well, from the rules of surds, I can split that up into 2 square roots, the square root of 9 over the square root of 10. So that's 3 over root 10. Square root of 9 is 3, and root 10 is already a simplified surd. And we'll just define the exact value of cos x, so we've done that, so we're done there. Differentiating a trig function, SQA Higher Maths 2016, Paper 2, Question 11. Show that sin 2x tan x equals 1 minus cos 2x, and then differentiate sin 2x tan x. So part A, sin 2x tan x, well, we can change sin 2x to 2 sin x cos x, and we can change tan x into sin x over cos x. So that gives me 2 sin squared x, and the cos x obviously cancel. So then as an aside, remember we've got a cos 2x on the right hand side. Well, cos 2x, using the expansion with sin squared x in it, is 1 minus 2 sin squared x. So we can rearrange that to get what sin squared x is. That means that 2 sin squared x, moving over to the right, equals 1 minus cos 2x. As required. Part B, f of x is equal to 1 minus cos 2x now. So f dash x, differentiating each function, 1 goes to 0, Cos, remember, goes to minus sine, so it becomes plus sine, so it's sine 2x because of minus minus. And then we need to, because of a chain rule, differentiate the inner function, which is 2, so times by 2. So we get 2 sine 2x. SQA Higher Maths 2017, Paper 2, Question 11, Trigonometric Identities. Part A, show that sine 2x over 2 cos x minus sine x cos squared x equals sine cubed x. So the way to deal with these is just keep it separate, start dealing with the left and start making it equal to the right hand side. You may have to manipulate the right hand side separately as well, so you get two different things equal, but in this case probably not. So let's look at the left hand side. We've got sine 2x, we can write that as 2 sine x cos x, just using the start of the exam paper, over 2 cos x. And then we've got minus sine x cos squared x. So we can cancel the 2's and we can cancel the cos x's from here. So that leaves just sine x for this one, minus sine x times cos squared x. Sine x is a common factor in this case, so that gives me sine x bracket 1 minus cos squared x, and if you're paying attention, you'll realise that 1 minus cos squared x is also equal to sine squared x. Just check the exam paper. Sine squared plus cos squared equals 1. So that means I can say that that is sine x times sine squared x, which is equal to sine cubed x, as required. Okay, part B, hence differentiate sine 2x over 2 cos x minus sine x cos squared x between 0 and pi over 2. So if we're going to differentiate that, we can just differentiate the right hand side because it's equal to it. So for part B, d by dx of the left hand side equals d by dx of what we just found out, sine cubed x. Now, sine cubed x, remember, means the sine of x squared. So it's easier to write it like that to see exactly what you're doing. So if I just write sine of x, that's to be cubed. So I have to differentiate sine x all cubed. So that's the chain rule. So the chain rule says I take the power down to the front, I leave the function alone, so it's sine x. And then I take 1 away from the power, so that's squared. But then I need to differentiate the inner function, which is sine x. Check the start of the exam paper, sine x goes to cos x, so times by cos x. Tidying that up, that's 3 sine squared x cos x. And we're done there. SQA Higher Maths 2024, Paper 1, Question 11. Express cos x plus root 3 sine x in the form k cos x minus a. And then we'll have to sketch a graph. Okay, let's start. So for part A, we've got cos x plus root 3 sine x equals k cos x cos a minus, so it becomes plus k sine x sine a. I mean, on the degree signs, you can put them in if you want. So then we compare coefficients. In front of cos x, we've got k cos a. So k cos a equals 1. And in front of sine x, we've got k sine. And in front of sine x, we've got k sine a. So k sine a equals root 3. So to get our k, it's the square root of 1 squared plus root 3 squared. That's the square root of 1 plus 3 is 4, which is 2. Then we can say that tan a is sine over cos, root 3. So then we do the inverse tan of root 3. Oh, that's an exact value. 60, 30, 2, 1 root 3. That's 60 degrees. And now we need to check, is it that one? So cast diagram. Sine was positive and cos was positive, so it is 60. So our final answer is 2 cos x minus 60 degrees. And we're done there. So usually a cos graph, just to give you this idea, up here goes to 1 and minus 1, but this one goes to 2 and minus 2. And it's shifted to the right by 60. So if we're shifting to the right by 60, its starting position here is 60 degrees. And then usually here we're at 90. So we do 90 plus 60 is 150. And then usually here we are at 180, so we do 180 plus 60 is 240. And then usually when we come back up, we are at 270, so we do 270 plus 60, which is 330. And we'll just show 360 here. So we're starting here, and we're just going down there, along and up. And then we won't kind of get there, it'll kind of all starting. And this one you can see we've gone there. Now you might be asking yourself, well, what about this point here? Could we work that out? Well, you actually can quite easily. The answer is 1. And the reason, I'm just going to put some of my numbers in, 60 degrees 2. And the turning point here is 240 degrees and minus 2. So to work that out is when x equals 0. So you've got 2 cos minus 60. Well, if you add 360, you don't have to get back into a standard place, that's 300. So we want to know the cos of 300. Well, that's related to an exact value. Cast diagram, 300's here, so that means it's 60. So I just want a cos of 60. Well, the cos of 60 using that triangle up here is a half. So it's 2 times a half, which is 1. So that's why I can put 1 on there quite easily. So I've done that just to be on the safe side. But basically, there's your graph, and we're done there. SQA Higher Maths 2023, paper 2, question 9. Express 7 cos x minus 3 sin x in the form k sin x plus a, so the wave function. So let's start off with expanding this. You've got k sin x plus a. So from the start of the exam paper, that's k sin x cos a plus k cos x sin a. And then we're just equating the left-hand side with the right-hand side from the start of the question. So looking at, if I highlight this, what's in front of sin x? I've got k and cos a. And what's in front of sin x in our question? Minus 3. So I can say that k cos a equals minus 3. Similarly, using a different colour highlighter for clarity, in front of cos x is sin a and k. And in front of cos x in our question is just the number 7. So I can say that k sin a equals 7. So now we can find k. To find k, because sine squared plus cos squared equals 1, if I square both of them, I will end up with k squared. So k is going to be the square root of 7 squared plus minus 3 squared. A bit like Pythagoras, essentially. So that becomes 49. And 3 3s are 9. So k becomes the square root of 58. I would usually use an exact value if we can. And then, because sine divided by cos is tan, I can say that the tan of a is equal to minus 7 over 3, or 7 over minus 3. So I can now work on a. The inverse tan of 7 over 3 is 66.8 degrees. So cast diagram, but it's not the cast on tan, remember, it's the cast on cos and sine, because that's what you started with. So looking at sine first, that's positive. So that is A and S. And then looking at cos, that's negative. Well, cos is negative on S and T. So therefore, the quadrant we want is this one, which is 180 minus. So that means that A is 180 minus 66.8, which is 113.2 degrees. So we've got our A, we've got our K. So to answer the question, it is root 58 sine of x plus 113.2 degrees for our mark. Now part B. Hence or otherwise find the maximum value of 14 cos x minus 6 sin x and the value where it occurs between 0 and 360. Well, notice 14 is double 7, 6 is double 3, so that is just double this. So I just need to double it. So I can say for part B, if I write it out, 14 cos x minus 6 sin x equals 2 times this, so 2 root 58 sine x plus 113.2 degrees. So for part 1, the max value, well, this is just a graphs question. It isn't a differentiation question. A normal sine graph goes up to 1 and minus 1, but it's been times by 2 root 58. So the max value is 2 root 58. Now we could simplify that by, well, not simplify it, we could have that as a decimal because you're using a calculator if you want, but 2 root 58 is fine. There's no square numbers that go into 58. Part 2, find the value of x for which it occurs. So this x plus 32 is 113.2 is telling you something. The sine x, its max normally appears at 90. If I just draw you a little graph, here's our normal sine graph there. And it goes to 1 and minus 1 usually, but for this one, it's going to go to 2 root 58 and minus 2 root 58. If this hadn't been shifted, this number here, its max, would be 90. But it's shifted to the left by 113.2 degrees. So all I need to do is do 90 minus 113.2. 90 minus 113.2 degrees gives me an answer which is negative. 90 minus 113.2 is minus 23.2 degrees. Well, that's no good because that's negative. I'm now in the left and I want it to be between 0 and 360. So to solve that is, remember, sine repeats every 360. So I'm just going to add 360 degrees and that will give me in the correct range 336.8 degrees, and we're done there. We've got expressed 4 sine x plus 5 cos x in the form k sine x at a, where k is greater than 0 and a is between 0 and 2 pi. Notice it's in radians, so I'll just work in radians for this question and then we'll have to solve the equation. Okay, let's do this. So part A, if I take k sine x at a, I can expand that straight away. Check the front of the exam paper if you're unsure. You'll get k sine x cos a plus k cos x sine a. So that means that 4 sine x plus 5 cos x equals k sine x cos a plus k cos x sine a. Well, 4 sine x, that's already got a sine x here, so that means that k cos a must equal 4. Similarly, we've got on this side cos x and this side cos x, so whatever's left, k sine a must equal 5. Sine divided by cos, remember, is tan, so if I divide at this moment in time, we'll get tan a straight away equals 5 over 4. We should check which quadrants a is going to be in. And we can do that by checking our original equations. This is positive, so we've got cos a. This is positive, so we've got sine in a. That means that the tan of this will only be positive on a because that's the one that's ticked twice. So we're using the first quadrant. That's nice and easy, so we can work out a straight away. A is the inverse tan of 5 over 4. 0.896. So we've got our a. Now we need to work out our k. But sine squared plus cos squared equals 1. So that means that 4 squared plus 5 squared equals k squared. So 4 squared plus 5 squared equals k squared. 16 plus 25 is k squared. So 41 equals k squared, which means k must be the square root of 41. I'll just leave it as a cert. As long as it's simplified, that's fine. Or you could just square root 41 in your calculator and you'll get 6.4, but better off with an exact value. So then just to answer the question, remember the question was expressed in the form k sine x add a. So as k sine x add a, we've got k sine x plus 0.896. Question 3b, hence solve 4 sine x plus 5 cos x equals 5.5 for x between 0 and 2 pi. So we've already worked out what we've got, root 41 sine of x plus 0.896. That's our left hand side, and that equals 5.5. So we can divide through by root 41, so that the sine of our angle plus 0.896 is just 5.5 over the square root of 41. So we can work out what quadrants we should be in with our cast diagram. So sine is positive, so we're in the first quadrant and the second quadrant, which reminder is going to be pi minus our angle. So we now need to work out our angle using the inverse sine in a calculator of 5.5 over root 41. If you do that in a calculator, you get 1.033. So in our first quadrant, that means that x plus 0.896, remember, equals 1.033. So taking away 0.896, we get x equals 0.137 as our first answer. Let's look at our second answer on our second quadrant. Remember, that means that we've still got x plus 0.896, because that's our whole angle, but that equals pi minus, remember it was 1.033. So x must be pi minus 1.033 minus 0.896, which gives us a second answer of 1.213. So we've got our two answers for x between 0 and 2 pi. Remember, I was working in radians there. SQA Higher Maths 2024, paper 2, question 12. Solve the equation, which is a trig equation, sine 2x, 2 sine 2x minus sine squared x equals 0. Let's expand that. So let's expand that. It's 2 times 2 sine x cos x minus sine squared x equals 0. So that's 4 sine x cos x minus sine squared x equals 0. That's a little bit tricky, that, because if you take sine x out as a common factor, you're going to get sine and cos in one of the brackets, and that's going to look really funky. So some of you might have been tempted to go sine squared plus cos squared equals 1. Maybe not get anywhere with that, but there are other trig identities you could have used, and one of them is sine divided by cos is tan. So if I divide by cos, you're going to, in a minute, once I take a common factor out, you'll see what's going to happen. So that's the route I'm going to take. I'm going to take common factor out of, not 4 of course, just sine x. And I get 4 cos x minus sine x equals 0. So I've got sine x equals 0, easy enough there. And 4 cos x minus sine x equals 0. So I'm going to divide the whole of this by cos x, because if I do that, divide both sides by the same thing, as that's allowed, I'll get rid of the cos x from the first term, and I'll get a tan x in the second term. So there's not a bit of trick there. So I'm going to divide this side by cos x, and similarly this side by cos x to be fair. So cos x divided by cos x is 1, so that gives me 4. Sine divided by cos is tan, so that gives me tan x. 0 divided by cos x is 0, and therefore tan x equals 4. And now I can solve both my equations. Inverse sine is 0. Well, you should know that. You need a calculator for that, but let's just check. There's your graph there. And we're in radians or not? Nope. So you've got 0, 180, and 360. Now be very careful here. X for this is equal to, the limit is between 0 is less than or equal to x, so 0 counts, but then less than 360, so 360 doesn't count. So it's just 0 and 180 degrees for this one. 360 does not count, it's outside our range. Inverse tan of 4 then make sure you're in degrees, 75.96. .96, and then cast diagrams, what a lot of people usually use, so I'll just use that. We're positive, so I can do 180 plus 75.96, which gives me 255.96. So x equals 0 and 180, and x equals 75.96 and 255.96. Or you might prefer 76 and 256, and that would probably be fine as well. Okay, we're done there. SQA Higher Maths 2023, Paper 2, Question 7. Solve sin x plus 2 equals 3 cos 2x. So it's a trig equation. I'm going to have to expand cos 2x, and I'm going to have to use the sine one. So I'm going to rewrite that as sin x plus 2 equals 3 times. If you go back to the start of your exam paper, cos 2x is 1 minus 2 sine squared x. So then we can start tidying that up. Sin x plus 2 equals 3 minus 6 sine squared x. I'm going to take everything over to the right because it's going to be a quadratic sine squared sine and a number. So taking the 6 across, I get 6 sine squared x. I've got plus sine x. And we've got 2, then take away 3 is minus 1, and that equals 0. So we want to find how to factorise this, and it will be factorisable. So I'm going to show you a way. I'm just going to kind of write m squared, 6m squared plus m minus 1, so you can see this. That's basically the same quadratic. Now, to factorise that, if I times the 6 and 1 together, I get 6. So I'm looking for numbers that times together to make 6, but add together to make the 1 in the middle. So that could be 6 and 1 or 3 and 2. Well, it's clearly 3 and 2. And how is it 3 and 2? Well, it's plus 3 minus 2 equals 1, and 3 times minus 2 is minus 1. So we can now split the middle term. So we've got 6m squared plus m minus 1 becomes 6m squared plus 3m minus 2m minus 1. And then we just factorise each side. So 6m squared plus 3m, 3m is a common factor, you get 2m plus 1. And you've still got 2m plus 1 on this side because you need it to be the same. And it's just going to be minus 1 then, times 2m plus 1. So factorised, that is going to become 2m plus 1 and 3m minus 1. So then taking this and making it our sign, that becomes double brackets, m is just your sine x. So we've got 2 sine x plus 1, and we've got 3 sine x minus 1. And you might have got to that factorisation just by looking. Great if you can. So that means 2 sine x plus, and that equals 0, remember. 1 equals 0, or 3 sine x minus 1 equals 0. So the left-hand side, sine x is equal to 1 becomes minus 1 over 2. Minus 1 over 2. And the other one, sine x, is equal to 1/3. So we need to do the inverse sine of just a half in a calculator. If you don't know it, it's a calculator paper after all. The inverse sine of a half is 30 degrees. That's the exact value. But we need a cast diagram to pick the correct values because our sign was negative. So when the sign is negative, it's in these two quadrants, which is 180 plus and 360 minus. So our first two answers for the left-hand side, are x equal 180 plus 30, which is 210, and 360 minus 30, which is 330 degrees. Now looking at our sine x equals 1/3, we do the inverse sine of 1/3 on our calculator. And if we do that, we get an answer of 19.47. And again, our cast diagram for that side, this time the sign was positive, so it's just 180 minus it. So our other answers are 19.47, and we do 180 minus 19.47 in our calculator, and that gives us our final answer of 160.53. Or you'd be fine with 19.5 and 160. SQA Higher Maths 2015, Paper 2, Question 9 for the addition and double angle formula. The winds of a turbine are turning at a steady rate. The height h of the tip of one of the blades above the ground at any time t seconds is given by the formula. Express 36 sine 1.5t minus 15 cos 1.5t in the form k sine 1.5t minus a. So we can write 36 sine 1.5t minus 15 cos of 1.5t equals, well, k sine 15t minus a. K sine 1.5t, minus a. So expanding the right-hand side, that's going to equal k sine 1.5t cos a minus k sine a cos 1.5t. If we look at what's in front of sine 1.5t here, we get 36. So 36 equals what's in front of sine 1.5t on this side, k cos a. And similarly, looking at what's in front of cos 1.5t on this side is minus 15. And in front of cos 1.5t on this side is minus k sine a. To rewrite that more nicely then, I can say that k cos a equals 36 and k sine a equals 15. And now we're ready to get our k. Because sine squared plus cos squared equals 1, that means our k squared will be 36 squared plus 15 squared. So in other words, k is equal to the square root of 36 squared plus 15 squared, a bit like Pythagoras. So that is the square root of 1521. Use your calculator to verify that. And the square root of 1521 is 39. So we know that k is equal to 39. And also we can work out our a because sine divided by cos is tan. So since tan a is sine a over cos a, I can write tan a is equal to 15 over 36. So I can find the inverse tan of 15 over 36. Inverse tan of 15 over 36, making sure my calculator is in radians, is 0.395. And now I just need to check which quadrant our angle is in. So drawing a cast diagram would help with this. Now remember, we're going back and looking at what cos and sine were. Well, we're both positive. So cos was positive, so that's A and C. And sine is positive, so that's A and C. So I'm in the first quadrant, so that means that A equals 0.395. And therefore, to answer our question, we get 39 sine 1.5t minus 0.395. And we're done there. So to follow on this question, it then says, and hence find the two values which tip of blade is at a height of 100 metres above the ground during the first turn. So we've just expressed this in this form, but then you've got plus 65 on the end. So we can just write that again, plus 65, and that's going to equal 100. So I'll go ahead and do that. So that means, I'll just call this part 2, our h equals 39 sine 1.5t minus 0.395 plus 65, and that's going to equal 100. So we've just got an equation to solve now. That means I can take the 39 with 65 across, so we get 39 sine 1.5t minus 0.395 equals 35. So dividing through by 39, we get sine 1.5t minus 0.395 equals 35 over 39. So at this point, I can find the inverse sine of 35 over 39 using a calculator and get a value. The inverse sine of 35 over 39 is 1.114. And looking at our cast diagram, sine is positive, so it's in the first and second quadrants, so that's pi minus the answer. So we can also do pi minus 1.114 to get a second solution, and that is going to be 2.03. So that means we can say that the whole of this equals that, and the whole of this equals that, and solve for t. So 1.5t minus 0.395 equals 1.114, and 1.5t minus 0.395 equals 2.03. So solving the first equation, 1.5t adding 0.395, we get 1.509. And therefore t is 1.509 divided by 1.5, 1.006. There's our first solution. And our second solution, 1.5t equals 2.03 plus 0.395, which is 2.425. And therefore t dividing through by 1.5, 1.617. Just put my units in here, so that's seconds and that's seconds. And we're done there. Related functions, SQA Higher Maths 2015, paper 1, question 4. The diagram shows the graph of a function y equals p cos qx plus r. So it's a trig graph. Write down the values of p, q, and r. Okay, so we need to start off with what this function is. The normal cos graph, if you remember, goes between 1 and minus 1, like so, and it goes up to 2 pi. So the number in front is called the amplitude, then the period of the frequency, and then how far it's moved up or down. So immediately we can see that if we look at the q first, we've got 1 up to pi over 2, which means if I was to keep drawing that, I would have 4 up to 2 pi, because pi over 2 is 90 anyway. So I can immediately write down that q equals 4, because I should have 4 of them up to 2 pi. Okay, to get our amplitude, if we just work out the difference between the maximum and minimum, I've got 4 and minus 2 is 6. So to get p, I can just do 4 to minus 2 is 6. Half of that is 3, so I get 3. P is 3. And then for r, well then now I've got p, it's easy. If it was just 3 cos x, it would go up to 3, but it starts at 4, so I've added 1. So r is just equal to 1. And we're done there. We'll write down the values of p, q, and r. In other words, the function is 3 cos 4x plus 1. SQA Higher Maths 2018, paper 2, question 8. The wave function, part A, express 2 cos x minus sin x in the form k cos x minus a. Okay, quite standard question here. If we're to express it as k cos x minus a, I expand k cos x minus a and then equate both sides. So for part A, I can write 2 cos x minus sin x equals, start of exam paper, k cos x minus a is k cos x cos a. And then it becomes plus k sin x sin a. Because k is times everything. You could have like k bracket that, then expand the bracket. It's quite easy to do it that way. So looking at what is in front of our cos x, on this side in front of cos x and attached to it is k cos a, and on this side it's just 2. So I can immediately write k cos a equals 2. And similarly, looking at our other sin x, that's attached to k sin a, and this sin x is attached to a minus, so a minus 1. So I can immediately write k sin a equals minus 1. And now we need to just get our k's and get our a's. So to get our k's, because sin squared plus cos squared equals 1, you can just write straight away that k is the square root of 2 squared plus minus 1 squared. Just like Pythagoras. That's the square root of 2 squared is 4 plus 1 squared is 1. That's root 5. So our k is root 5, and that's a simplified third. We'll now work on getting our a. Because sine divided by cos is tan, I'll show you that here. Tan a is sine a over cos a. Tan a equals sine a is minus 1, or k sine a is minus 1, and k cos a is 2. But the k's cancel when you divide them, so you just get minus a half. So I need to do the inverse tan of a half. So the inverse tan of a half is 26.6 degrees. And then using our cast diagram to see which quadrant our angle is in. Now remember with this one, although it's tan A is negative, so you're tempted just to say T, S and C, it's to do with what sine and cos were. So sine was negative and cos was positive, so we tick for cos and sine. So when cos is positive, it's these two, and when sine is negative, it is these two, so it's in the fourth quadrant. So that means that our A degrees is equal to 360 minus 26.6. So A is equal to 333.4 degrees. And now we just write our answer as K cos x minus A. So our answer is root 5 cos x minus 333.4 degrees. And we're done there for part A. Part B hence allows us to find the maximum and minimum value of 6 cos x minus 3 sin x, and then find the value for which it occurs between 0 and 360. Well, if you look at this one here, that times 3 gives you this one here. So if I just times my answer by 3 to part B, I can find the max and minimum values. Well, just the minimum. Part B, since it is 3 lots of it, I can say we've got 6 cos x minus 3 sin x degrees is equal to simply 3 times the answer we just got, which is root 5 cos x minus 333.4 degrees, because it's a multiple. Okay, minimum value of this, well, let's look at a cos graph in general. A normal cos graph goes between 1 and minus 1. This is the amplitude, so this one goes between 3 root 5 and minus 3 root 5. So straight away we can say that our minimum value is minus 3 root 5. So there's our first thing, and then we have to work out where it occurs. So where does the minimum value normally occur? Well, usually it goes 90, 180, 270, 360. But this here, x minus 333.4, means it's been shifted to the right by 333.4. Now, if I shift from 180 to the right, it will take me outward for 360. So I need to find the next value. So you could just go up and then take away 360. Or if you imagine the cos graph continuing behind me, that would be minus 180. So I can just do that shifted to the right. I would get 333.4 minus 180. If I do that sum, I get 153.4. So it occurs at 153.4 degrees, and we're done there. Trigonometric equations, SQA Higher Maths 2019, paper 1, question 15. Solve the equation sin 2x plus 6 cos x equals 0. And then solve a new equation for part B. So for part A, sin 2x plus 6 cos x, a sin and a cos, they're different from each other. So I will expand the sin 2x to give me 2 sin x cos x. And this time we're working in degrees, plus 6 cos x equals 0. So although we've got a sin and a cos, there is a common factor, so I can factorise. So the common factor is cos x, but it's also got a number attached. 2 is also a common factor, so 2 cos x goes outside. That gives me sin x in the bracket here. And 2 cos x times 3 is 6 cos x, so plus 3 equals 0. And then we've just got 2 equations to solve. We can say 2 cos x equals 0, or we can say sin x plus 3 equals 0. This one gives me sin x is equal to minus 3, which has no solutions, because the maximum and minimum of sin x is 1 and minus 1. So this one, 2 cos x equals 0, means that cos x also must be 0. You should know that cos x is equal to 0 at 90 degrees. If you don't, there's a little graph for you just to prove it. 1 and minus 1, it goes along 90, then 180, then 270. So we can immediately say that x equals 90 degrees. You could also say it's 270 straight away, but if you didn't know it was 270, cast diagram would give you the other one because cos is positive. So 360 minus 90 would give you your 270 as well. And we're done there for part A. Part B says, hence solve sine 4x plus 6 cos 2x equals 0. Part B, sine 4x plus 6 cos 2x equals 0. So part A was sine 2x plus 6 cos x. So the numbers in front haven't changed, so it's not a multiple. However, the angles have just doubled, so the frequency's just doubled. So that means that our answers to part A was when x equals 90 and 270. So now it's just 2x equals 90 and 270. There's no real extra work to do. So for part B, I can just say straight away 2x degrees equals 90 degrees and 270 degrees. But I want to solve it between 0 and 360. So there's going to be more solutions than that because I'm going to divide my answers by 2. So I just add 360 to everything. I'll just write that here, plus 360. Then it's going to give me 450 degrees. And it's also going to give me 630 degrees. And then I can just divide each of them by 2 to get 45 degrees, to get 135 degrees, to get 225 degrees. And the final one is 315 degrees. And we're done there. SQA Higher Maths, Paper 1, Question 4. Y equals the square root of x cubed minus 2x to the power minus 1, where x is greater than 0. We have to differentiate this expression, so let's get ahead and do that. So our first step, or our first mark, is to rewrite the square root of x cubed is x to the 3/2. And we've still got minus 2x to the minus 1. If we've written that, we get a mark there for this x to the power 3/2. We now need to differentiate our terms. So our first mark is for differentiating our first term, which is 3 over 2. X, take away 1 from 3/2, and that's 1/2. There's a mark there. And then differentiating our second term, minus times a minus is a plus, so it's plus 2x to the power of minus 2, taking away 1. So our final mark is 1 here and 1 for this term here. We do not have to go any further than that in this question. So if you did go further, that's fine, but you don't have to. SQA Higher Maths 2023, Paper 1, Question 1. Y equals x to the 5/3 minus 10 over x to the 4. So we need to get it ready to differentiate first to find the y by dx. So y equals x to the 5/3 minus 10 x to the minus 4. And then I can do the y by dx. Take a power to the front. Take away 1, so that is 2/3. And then take the power to the front in times, but minus times a minus is a plus, so plus 40 x to the minus 5. You probably don't need to go any further, but just for the sake of completeness, that would give you 5/3 x to the 2/3 plus 40 over x to the 5, and we're done there. SQA Higher Maths 2017, Paper 1, Question 8 on differentiating a polynomial. Calculate the rate of change of d of t is equal to 1 over 2t. So we need to get it ready to differentiate. Always need to do that. So d of t is equal to 1 over 2t to the minus 1. Do not be tempted to move this 2. That's just a half still. Separate it out. It's just the t that's moving. Once we do that, d dash t, take the minus 1 down, so we get minus a half t. Take away 1 from the power, we get minus 2. And we have to work it out when t is 5. So d slash 5 is equal to minus a half times 5 to the minus 2. Or minus 1 over 2 times 5 squared. Minus 1 over 2 times 5 squared is 50. So minus a 50th. Just a note, remember, rate of change means differentiate. Okay, differentiating a trig function. SQA Higher Maths 2018, Paper 1, Question 3. H of x is 3 cos 2x, find h dash pi over 6. So if h of x is 3 cos 2x, then h, straight away you can just do h dash x is equal to minus sine 2x, well, minus 3 sine 2x, but then we need to times by 2 because we need to differentiate the 2x part as well. So that's minus 6 sine 2x. This is a paper 1 question, so it's an exact value question. So h dash pi over 6 is equal to minus 6 times sine 2 pi over 6. Subbing it in. That equals minus 6 times the sine of pi over 3. Or if you prefer to work in exact values in degrees, that would be 60. So that equals minus 6, the sine of 60, root 3 over 2. 6 divided by 2 is 3, so it's minus 3 root 3. And we're done there. One question 12 was, given f of x is 4 sine 3x minus pi over 3, evaluate f dash pi over 6, or f dash, differentiate your function at pi over 6. So, f dash x, we can check the front of the exam paper to realise that sine becomes cos when you differentiate it. So you should first of all start by writing 4 cos 3x minus pi over 3. And just for doing that part without actually finishing the differentiation, which I'm going to do in a moment, gets you your first mark. For your second mark, you have to then realise that this is the chain rule. So you've got an inner function of 3x minus pi over 3. So you need to differentiate that and times the whole thing by that. So in other words, if I differentiate this part, that's the constant, so that's nothing. Differentiate 3x is 3. So I need to times by 3. So we get a second mark for realising that and writing down that we're going to times by 3. And then our final mark, of course, is evaluating it. So I need to tidy it up and then substitute pi over 6 in. So f dash x equals 12 cos 3x minus pi over 3. So f dash of pi over 6. And this is an exact value, remember, because we are non-calculator. But I'll substitute it in first. 12 cos 3 pi over 6 minus pi over 3. We need to tidy that up. So that's 12 cos 3 pi over 6 minus 2 pi over 6, which is 12 cos 3 minus 2 is 1, so it's just pi over 6. Pi over 6, if you prefer to think in degrees, is 180 divided by 6, which is 30 degrees. So it's the pi cos of 30. If you're not sure of what that is, let's draw an exact value triangle. If this was 60 degrees, that would be 30 degrees up here. This would be 2, this would be 1. 2 squared is 4, minus 1 squared is 1, so that gives you 3. So we get the root 3. And we're looking at the cos, so it's opposite adjacent over hypotenuse, root 3 over 2. So you get 12 times the cos times root 3 over 2. 12 divided by 2 is 6, so you get 6 with the root 3 as your final answer. And for all of that extra work, it's 1 extra mark. A bit stingy of the SQA there. So there's our final mark at this point here. SQA Higher Maths 2024 Paper 1 Question 3. Y is 5x squared plus 3 to the 7. Find the y by dx. So this is the chain rule. So dy by dx equals, I'll take the 7 down, leave the function alone, 5x squared plus 3, and take 1 away for power, that's 6. And then I need to times by the bracket differentiated. So 5x squared becomes 10x. 3 is nothing. So then that just equals 7 times 10 is 70x. 5x squared plus 3 to the power of 6. And we're done there. Okay, the chain rule, SQA Higher Maths 2019 Paper 1 Question 6. Given that y equals 1 over 1 minus 3x to the half, and x is not a third, find the y by dx. Let's get it ready to differentiate. So y equals 1 minus 3x to the minus 5. So the y by dx minus 5 in the front, 1 minus 3x, take away 1 from the power, so that's minus 6, and then times by whatever's in the bracket differentiated, which is minus 3. So tidying that up, we get minus 5 times minus 3 is 15. 1 minus 3x to the minus 6. And we're done there. SQA Higher Maths 2024 Paper 1 Question 12. a function f is given by f of x is 12 cube root of x is greater than 0. And it says when x equals a, the rate of change of f with respect to x is 1. Rate of change differentiation. Find the value of a. So let's differentiate it to find the rate of change. So I'm going to need f of x in a differentiable form. So I'm going to say 12x to the cube root of x. Cube root is a third. So that means I've got a third times 12x. Take away 1 to the power minus 2 thirds. A third of 12 is 4. So I get 4x to the minus 2 thirds when we differentiate. And it says when f of a, when x equals a, the rate of change with respect to x is 1. So when x equals a, so f dash a, f a minus 2 thirds equals 1. So we need to solve this equation. So there's lots of ways you could do this, but I'm going to actually just put it back into 4 over a to the 2 thirds equals 1. So that means that a to the 2 thirds equals 4. So what is a to the 2 thirds? That's the cube root of a squared equals 4. So if I just cube both sides, that'll give me a squared, and 4 fours is 16 times 4 is 64. And the square root of 64 is 8, and x is greater than 0, so it is just 8. And we're done there. SQA Higher Maths 2023, paper 2, question 5. A function is defined as f of x is 3 minus 2x to the 4. Calculate the rate of change of f when x equals 4. So again, a power word, the rate of change means differentiation, and then just sum when x equals 4. So f dash x, well, it's the chain rule, so I take 4 down to the front, times by 3 minus 2x, take away 1 to the power, which is 3, but then I need to differentiate then a function, which is minus 2, so I'm timesing the whole thing by minus 2. So f dash x is minus 8, 3 minus 2x cubed, because of the chain rule. Substituting in 4, f dash 4 is minus 8, 3 minus 2 times 4 cubed, that's minus 8, 3 minus 8 cubed, which is minus 8 times minus 5 cubed. Minus 5 cubed is minus 125. 8 times 125. 8 times 125 is 1000. Minus times a minus is a plus. So there we are. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined as a set of real numbers given by f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equals to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. Since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there. The range of values for which the function f of it, SQA Higher Maths 2023, paper 2, question 10. Determine the range of values for which the function f of x is 2x cubed plus 9x squared minus 24x plus 6 is strictly decreasing. There's actually 2 ways to do this. Both involve stationary points. If you get the stationary points, you can then examine the graph to see where the derivative is negative, or you can just examine the nature of the stationary points. So let's just look at the stationary points first. Stationary points occur when f dash x is 0. So f dash x gives me 6 2's is f dash x, 3 2's is 6, 6x squared, 2 9's is 18, plus 9 18x, and minus 24. And I'm going to look at that equal to 0 for our stationary points. 6 is a common factor, so I get x squared plus 3x minus 4 equals 0. So double bracket that up. X and x. 4 and 1 make 3, plus 4 minus 1 makes 3, so that implies our stationary points occur when x equals 1 or x equals minus 4. So then there's two ways to go now. I'll give you both options. I'll use the nature table. If you're using a nature table, you'll go along to minus 4, along, and then along to 1, and then along. And then you're just going to examine the derivative. So looking at our derivative, a number before minus 4, let's try minus 5. Minus 5 minus 1 is minus 6. And minus 5 plus 4 is minus 1. A minus times a minus is a plus. So it's positive there. It's 0 here. Between these two numbers, let's just try 0 then. Minus 1 times 4 is minus. It's negative there, so it's still negative there. It's 0 there. And then a positive number like 2. 2 minus 1 is 1. 2 plus 4 is 6. Positive times a positive is a positive. So it's increasing before minus 4. And then it's a turning point. And then it's decreasing. Still decreasing, of course. And then it's increasing. So we could say strictly decreasing when minus 4 is less than x is less than 1 in between those two numbers. Or if you, and that works as well because the function is continuous. If it was discontinuous, you'd be a little bit knackered, but we know it's continuous because it is. Now, if we move on to the other way, we could look at just the graph. So graph of the derivative, we know the derivative is quadratic with stationary points at minus 1 and 4. So 1 and 4, so 1 and minus 4, sorry. So 1 and minus 4, and it's a normal there. So same idea. That's the graph of the derivative. That's the graph of f dash x. And that's negative below the x-axis, which is down here. So it's between minus 1 and 4. So again, you would stay the same answer. Minus 4 is less than x is less than 1. Either of those options will give you your marks probably. SQA Higher Maths 2024 Paper 2 Question 2. A curve has the equation y equals a over x cubed, x is greater than 0. Find the equation of the tangent at x equals 2. So equation of the tangent means differentiation to find the gradient, and then sub x into y to find the point, and then use straight line stuff as normal. So let's just differentiate this. We've got y equals ax to the minus 3. So the y by dx is minus 3 times a is minus 24x. Take 1 away for the power is minus 24 over x to the 4. And since because I don't like using a calculator that much, I'll just put that as x to the 4 in the bottom. So at x equals 2, the gradient is equal to minus 24 over 2 to the power of 4. Well, 2 2s are 4 times 2 is 8 times 2 is 16. So that's minus 24 over 16. And 8 goes into both of them. 8 3s are 24 and 8 2s are 16. So minus 3 over 2. But again, use a calculator anytime you want. So now we need a point. So when x equals 2, y equals 8 over 2 cubed. Well, that's quite nice because that's 8 over 8, which is 1. So our point is 2, 1. And we've got our gradient. So now it's just y minus b equals m x minus a. I'll just take the 2 up, and a lot of people would do that, I think. So expanding, 2y minus 2 minus 3x plus 6, watch for your minus minus. And I'll just take everything over to the left, 2y plus 3x minus 2 minus 6 is minus 8, and that equals 0. Or you can leave it in any other form you want, 2y plus 3x equals 8. Or you can even divide 3 by 2, but I don't know why you would. And that's us done for this question. SQA Higher Maths for 18, Paper 1, Question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, the y by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0 plus 2 equals 2. So our gradient equals 2, and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equal to 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. SQA Higher Maths 2023 Paper 1 Question 8. A function is defined in a set of real numbers by x cubed plus 3x squared minus 9x plus 5. Find the coordinates of the stationary points of f and determine their nature. Stationary points means derivative equal to 0. So we can write stationary points occur when f dash x equals 0. So f dash x is equal to 3x squared. 2 times 3 is 6, so 6x minus 9, and then the 5 disappears. So we're saying 3x squared plus 6x minus 9 equals 0. 3 is a common factor, so we get x squared plus 2x minus 3 equals 0. It's keeping our common factor, a standard one to factorise. We've got x and x. It has to be 3 and 1. And plus 3 minus 1 is 2. So that implies x minus 1 is 0, so x equals 1. Or x plus 3 is 0, so x equals minus 3. So we've now got our x part of the coordinate. We might as well try and find our y part. So when x equals 1, y equals, substitute into the original, x cubed plus 3x squared minus 9x plus 5. 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So that gives me y equals 1 plus 3 minus 9 plus 5. Y equals 1 plus 3 is 4. 4 plus 5 is 9. Minus 9 is 0. So our first coordinate is 1, 0. When x equals minus 3, we can do the same thing. So y would be minus 3 cubed plus 3 times minus 3 squared minus 9 times minus 3 plus 5. So keeping your wits about, because it is an on calculator, 3 cubed is 27, so you get minus 27. 3 squared is 9 times 3 is plus 27. 9 times 3 is 27, but it's plus because of a minus times a minus. And then you've got plus 5. Minus 27 plus 27 is obviously 0. So then you've got 27 plus 5, 32. So your second stationary point is minus 3, 32. So there's my two stationary points. Now we need to determine our nature by using a nature table. So a nature table is like this. We're going to go along to our first point. This is our x, so minus 3. And then along. And then we're going to examine the other stationary point. So I'm going to go along to 1. And then along. I always keep it separate in case there's a point of a discontinuous point. I don't want to lose marks for it in this case, but just in case. So then we're just looking at our derivative, f dash x. So picking numbers, we know that at minus 3 it's 0, and at 1 it is 0. So we need a number less than minus 3. Now, it's always best just with a derivative to examine it already factorised. So just pick a number less than minus 3. Let's just pick minus 4. Minus 4 minus 1 is negative. Minus 4 plus 3 is negative. A negative times a negative is a positive. So I know it's positive before minus 3. So I can just write that. And after minus 3 but before 1, let's just put 0 in. That gives you negative. And that gives you positive. Negative times a positive is a negative. So we know that it's negative here. And therefore, after minus 3 but before 1, it's still negative. After 1 though, just pick 2. 2 minus 1 is positive. 2 plus 3 is positive. Positive times a positive is a positive. So we get a positive again. So our shape, it goes up, along, and down. So max, down, along, and up. So it's a min. So we need to state that. So minus 332 is a maximum turning point. And 1, 0 was it? 1, 0 is a minimum turning point. And we're done there. Stationary points under nature, SQA Higher Maths 2019, paper 1, question 1. Find the x-coordinates of the stationary points on the curve with equation y equals a half x to the 4 minus 2x cubed plus 6. Stationary points occur when the y by dx equals 0. So we can find the y by dx. 4 times a half, well that's 2x cubed, take away 1 from the power. 3 times 2 is 6, so minus 6x squared, and then 6 goes to nothing. In our little statement, stationary points occur when the y by dx equals 0. We've got 2x cubed minus 6x squared equals 0. Common factor of 2x squared to get x minus 3. And that means that x equals 0 because 2x squared equals 0, or x equals 3. And there we are. Simple as that. Graph of a derived function. SQA Higher Maths 2019, paper 2, question 5. The diagram below shows the graph of a cubic with stationary points at minus 2 and 4 as shown on the diagram in your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic. So we're expecting a quadratic either going down the way or up the way. And we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when the y by dx is 0, which means that these are my roots. So I get a root at minus 2 and a root up at 4. So that means that if we examine before minus 2, it's going up the way, it's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before minus 2, it's below, in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high, I'm dropping below between the numbers, and then I'm going high again. So my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the derivative. SQA Higher Maths 2018, paper 2, question 9 on differentiation and optimization. A sector with a particular fixed radius x and the perimeter p of the sector is given by this. Find the minimum value of p. So stationary points occur when you differentiate and make it equal to 0. So starting with p of, that's a function of x, that's 2x plus 128 x to the minus 1. So p dash x is simply 2 minus 128 x to the minus 2. or it's equal to 2 minus 128 over x squared. So stationary points when p dash x equals 0. So that gives me 2 minus 128 over x squared equals 0. So we need to solve that equation, so getting rid of a denominator. So we have got, imagine that's over 1. Common denominator is x squared. You get 2x squared on the top minus 128 equals 0. So then we can just say that that's like over 1, 0 times x squared 0, and this times 1. So we get 2x squared minus 128 equals 0. Simple to solve that one. We'll just say 2x squared is 128. And x squared then is half of that, which is 64. So x is the square root of 64. So x would equal 8 or minus 8, but x is greater than 0, so we can just disregard that one. So we've got x equal to 8. We now need to do a nature table to make sure that it's a max or a min. So looking at our nature table, we've got x, we're going along A8 and along, and then we're looking at p dash x. So a reminder of p dash x, it was 2 minus 128 over x squared. Now obviously you can't pick 0 because you divide by 0, so any other number, 1 maybe, and 10. If I put 1 into this, I get p of 1, p dash of 1 even, is equal to 2 minus 128. Well, that's clearly negative. That's 0, and then if I put p dash 10, that's 2 minus 128 over 100. Well, that's 2 minus 1.28, which is positive. So our shape is down, along, and up. And therefore, x equal to 8 is a min turning point. We have to find the minimum value of p. So remember, p of x was equal to 2x plus 128 over x. So at 8, that gives me 2 times 8 plus 128 over 8. That's 16 plus 1, and that gives me 4. 8 5s are 48, 6 is 48, which is 32. Well done here. Then the coordinates of the station points in the curve with equation a third x cubed minus x squared minus 3x plus 1, then the greatest and least values between that interval. Well, let's do part A first. Stationary points occur, you need to write this, when the y by the x equals 0. So what's the y by the x? 3 times a third is 1, so it's just x squared minus 2x minus 3, and we're going to say that equals 0. So we should be able to solve that. Let's hope it factorises. X and x, 3 and 1. And we've got minus 3 plus 1 is minus 2. So there we go. So x is minus 1 or x equals 3. Now read the question, determine the coordinates. So when x equals minus 1, y equals 1/3 minus 1 cubed minus minus 1 squared minus 3 times minus 1 plus 1. So minus 1 cubed is minus 1, so that's minus 1/3. Minus 1 squared is 1, times a minus is minus 1. Minus 3 times minus 1 is plus 3, and then I've got plus 1. So I've got 1 minus 1, 0. 3 minus 1/3 is 8/3. But you can use a calculator anytime you want. So the coordinate is minus 1 8/3. So that's our first coordinate. And our second coordinate, when x equals 3, y equals 1/3 times 3 cubed minus 3 squared minus 3 times 3, and then we've got plus 1. So 3 cubed divided by 3, 3 3s are 9, 3 is 27, divided by 3 is 9. 3 squared is also 9. 3 3s is 9, plus 1. 9 minus 9 is 0, minus 9 is minus 9, plus 1 is minus 8. The coordinate is 3 minus 8. and we've got both our coordinates. Notice it doesn't actually mention to find our nature, so there's no actual real need to do so. Part B. Determine the greatest and least values of y in the interval -1, x, and 6. -1 is less than x is less than 6 in the equation. A third x cubed minus x squared minus 3x plus 1. Now, with this is us testing limits here. Now, at the end, either the max and min occur at the end of these points, or they occur in the middle, in which case you occur at a turning point. Now, one of the turning points is already -1, so we've already checked -1 is 8/3. So when x equals -1, we can already say that y is 8/3. We've already got a 3 for our turning point. When x is 3, y is -8. So now we just need to check 6 to see if that one is bigger or smaller. So when x equals 6, y is 1/3 times 6 cubed minus 6 squared minus 3 sixes plus 1. Hopefully you can kind of see that this is going to be a big number, because let's just get a calculator. 6 cubed divide that by 3 is 72 minus 36 minus 18 plus 1. Now, since I've got a calculator out, I'm not going to be stupid, I'm going to actually use it. That is 19. So then we just say the answer. Now just answer a question. The greatest value is equal to the biggest of all the numbers. We've got 8/3 minus 8 and 19. 19, you could say at x equals 6. You don't need to. And the least value is the smallest number, which is -8. And that occurs at x equal 3. And we're done there. Okay, stationary points under nature, SQA Higher Maths 2017, paper 2, question 7. Find the x coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when the y by dx is 0. So we need to get it ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cube comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1 is 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9, minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3s are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4, minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. The derived function, SQA Higher Maths 2019, paper 2, question 5. The diagram below shows the graph of a cubic with stationary points at -2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic. So we're expecting a quadratic either going down the way or up the way. And we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when dy by dx is 0, which means that these are my roots. So I get a root at -2 and a root up at 4. So that means that if we examine before -2, it's going up the way, it's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before -2, it's below in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high, I'm dropping below between the numbers, and then I'm going high again. So my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the SQA Higher Maths 2024, paper 2, question 4. The diagram shows the graph of a quartic function. Wow. The maximum turning point occurs at -1, 3. The graph of y equals f of x has a point of inflection at x equals 2. And always a turning point that doesn't turn, keeps going down. And determine the coordinates of the maximum turning point of the graph of y equals f of x -4 plus 2. Well, the turning point to start with is -1, 3. So we're starting with -1, 3. Now this bit here, the bit that says x -4 means a shift to the right by 4. So I'm going to go right by 4. And then the bit at the end, plus 2, up by 2. So that becomes -1 shifts to the right, -1 add 4, that gives me 3. 3 goes up by 2, that gives me 5. 3, 5, job done. Part B. In the diagram in your answer book, sketch the graph of the derivative, y equals f dash x. So I've got a method for this, and this is my method that I use. I do this as if I'm doing a nature table, basically, and I'm going to say that's my derivative, and I'm going along to the turning points, because the turning points on the graph of the derivative turn into roots, because the 0 gradient. So the first turning point is -1, and then we go along, and we get another turning point at 2, and then we go along, and then we just examine what happens before and after this turning point. So checking my graph, I'm going up the way, so that's positive, then I'm going down, that's negative, and then I'm going down again, that's negative. So it's positive, negative, negative. So I can just write that. So the first one is positive, that's 0, negative, that's 0, and negative. So in terms of thinking about where I'm drawing this, I'm drawing that above the x-axis, on it, below it, on again, and then below. So then what you do is you get your diagram. Now I've not got one because I've not got an answer book yet, because I'm not a student. So I'll just draw it by hand. X and y. You put your turning points on as your roots, -1. Let's just call that 2. And I'm thinking I'm above before -1, so I'll just put a wee mark, just to remind me. And then I'm below after -1. And then I stay below. And then I need to go back up here and then go down a low. So that must be a turning point that I just touch and hug. So we can just kind of think of this as we're going to go down, we need to go up at some point, and then we're going to go back down. So that looks like a decent graph, and we're done there. It consists of a rectangular pond surrounded by a path. The length and breadth for x and y, and the path is 1.5 metres wide at the pond ends and 1 metre on the other sides, as shown. The total area of the pond in the path is 150. Show that the area of the pond is given by this equation. Well, we know the total area all the way round is x times y, or y times x. So we know, first of all, for part A to start with, that the area, total area y times x must equal 150, because it says so in the question, 150 square metres. If we go back up to the diagram, this distance here is going to be x minus 1.5 and 1.5, so 3. Similarly, going along the way, that distance there is going to be y minus, and you've got 1 and 1, so 2. So clearly the area of the pond part is y minus 2 times x minus 3. So the area of our pond, y minus 2 times x minus 3. We'll call that A. Now notice there's a y in here, but our question doesn't have any y's, but we know that y times x equals 150, so putting that back up there, y is 150 over x. Keep that in mind because we can substitute that in for y later on. Let's multiply our brackets out here. A equals yx or xy minus 3y minus 2x plus 6. Substituting our y in, which is 150 over x, we get 150 over x times x minus 3, 150 over x minus 2x plus 6. So that simplifies to 150 minus 450 over x minus 2x plus 6. So 150 plus 6 is 156 minus 2x minus 450 over x. That's now a function of x. And that's exactly as required. So we've done part A. Part B, determine the maximum area of a pond. This is called an optimization question. So in this case, we need to differentiate it and find the stationary points. So A dash x, we're going to have minus 2. And if I take a little note up here, minus 450 over x is minus 450 x to the minus 1. So we've got minus 2, then plus 450 x to the minus 2. Or, in other words, a dash x is minus 2 plus 450 over x squared. Clearly x cannot equal 0. So max or min stationary points we're looking for. So we want to set a dash x equal to 0. So that gives us minus 2 plus 450 over x squared equals 0. So multiplying through by x squared to eliminate the fraction, we get minus 2x squared plus 450 is 0. So 2x squared equals 450. X squared is 225. And therefore x is the square root of 225, which gives us two answers, plus or minus 15. X squared equals 225, so x equals 15. We can discount the negative value based on the question and do a nature table for just x equal to 15. So we've got x up to 15 and then at before 15. So at 15 we have got it being 0. If we pick a value before 15 but not 0, as you know, then you will see that you'll have 450 over 1, take away 2, which is positive. And if you pick a number after 15, let's just pick a massive number, 100. If we did 450 over 100 squared, that'd be a very small number. Take away 2, it's going to be a negative answer. So it's negative. So the max area, A of x, was equal to 156 minus 2x minus 450 over x. So at 15, we get 156 minus 2 times 15. minus 450 over 15. That's 156 minus 30 minus 30 again, which is 96, so meters squared. SQA Higher Maths 2023 Paper 2 question 14. The net of an open box is shown. The base is 3x by 2x with a height of h. Find the area of a net in terms of h and x. So for part 1, we've got 3x times 2x for this bit here. And then this will be 2x because it's just going to go up the side with that. So that's 2x. And obviously this is 2x as well. We've got 3x here. And then if you just imagine that over the top or around the front, this will also be 3x. So you've got 3, 4, 5, 6, 7, 8, 9, 10. So it's plus h times 10x. So that gives you 6x squared plus 10hx. And it's only worth 1 mark, so there we are. Part 2, given the area is 7,200 centimeters squared, so the volume is given by this. Well, volume of a cuboid is the area of the base times the height. Well, the base is this bit here, which we already know is 6x squared. So that's 6x squared h. But that's got h in it, so we need to get rid of that h. But we already know that 6x squared plus 10hx equals 7,200 from the question. So we can rearrange that to find h. So 10hx is 7,200 over 6x squared. So h is, so 10hx is 7,200 minus 6x squared. So h is 7,200 minus 6x squared all over 10x. So now our volume is just going to be 6x squared times the whole of that. I've not simplified that yet because I'll just simplify at the end. So 7,200 minus 6x squared over 10x. So that means our volume equals, well, dividing through by 10 first, I think, we'll get 6x squared, 720 over x minus 3/5 of x. So what I've done there, divided this by 10, so it's still over x, and then dividing this by 2, you get 3/5. X squared over x is just x. So now I can expand the bracket. 6 times 720 is actually 4320. Use a calculator, so you get 4320. X squared over x is just x. And then 6 times 3 is 18 over 5. We'll just leave it like that. Yep, minus 18 over 5. And we get x cubed. Part B, determine the value of x, which maximises the volume of the box. So it's maximise, optimise. Let's go. So for part B, to maximise the box, we need to examine stationary points. So stationary points occur when the derivative equals 0. So v dash, well, as a function of x, I suppose, is equal to 4320. And that's going to be minus 18 times 3 over 5 x squared. So v dash x is 4320. 3 times 18, 3 tens are 30, 3 eighths is 24, so that's 54. So minus 54 over 5 x squared. And we're going to make that equal to 0. So we can say that 54 over 5x squared equals 4320, just like that, taking that over to the other side. So dividing, times them by 5 and dividing by 54, I'll do that. So actually 54x squared equals 5 times 4320, which is 21600. So x squared is the square root of, divided by 54 is 400. So x is the square root of 400, which is equal to 20. Now just have a little note on this. It's actually equal to minus 20 as well, but you can't have a negative length, so it's only 20 the one we're picking. So it's just 20 we're looking at. Now we just need to check, is that a max or is that a min? So x along to 20 and along, examining the derivative to see if it's a max or a min. Okay, so we need to examine before and after 20. So let's try a number before 20. So let's try 19. 19 squared times 54 divided by 5. That number is smaller than this number, so that minus that is positive. So it's positive before 20. It's 0 at 20. Then if you try 21, the same idea. 21 squared times 54 divided by 5 is bigger than 4320. So 4320 minus that is negative. And therefore, we've just worked out that x equals 20 is a maximum turning point. So the box is maximized by x equals 20. Is it centimeters? Yeah. Centimeter. And we're done there.
Question carefully is really just an optimization question. Have a look, see if you can have a go at it, and then come back when you're done. Minimize the cost of production. Minimize optimization. That's your key power word for higher maths there. Let's try part A in any case. So there is our box and all the information in it, and I want the surface area. So I'm just going to start working on it and see if I can get the answer close to what we have got. So surface area, we've got 3x times h, and I can see I've got 1 of them, 2, 3, 4 of them. So first of all, I can write down I've got 4 times 3x h. I'll put a dot for times in so it's clear. And then I need to add on. Well, I've now got my top and my bottom. So my top is going to be 3x times 3x. So that's 9x squared. Times that by 2. So plus 9x squared plus another 9x squared, just to be clear, but or 18x squared straight away. But then you've also got a whole in the top, which is x squared by x squared, and I've got 2 of them, so take away 2x squared straight away. And then the bit that everybody can't always forgets, I almost forgot it, there's a surface inside this tube as well, so I need to work out what that surface is. Well, there's going to be 4 of them, and it's just going to be x times h. So plus 4xh. Tidying all that up a little bit, my area is 12xh plus 4xh. That's just my first and my last one. And then my x squared is 9, 18 minus 2 is 16x squared. Or my area is 16xh plus 16x squared. If you can get that far, you're getting a mark. But we're not finished there because our area in the question's not got any h in it. So we need to work out if we can eliminate that h somehow. Well, let's look at the information. The volume is 2000. Well, volume is length times breadth times height. So if I write that down underneath, volume is length times breadth times height. Volume of the big box, which is 3x times 3x, which is 9x squared times h. So 9x squared h, but we need to remember to take away the whole, which is x by h. So that's just x squared h. So our volume, 8x squared h, but that equals 2000, it says. So I can now eliminate h from my area by rearranging this equation to make h the subject. So that means that h equals 2000 divided by 8x squared. A mark for getting h. Now we just need to substitute it into a. So our a is 16x times h, 2000 over 8x squared. And we've got still plus 16x squared. Using a calculator, 16 times 2000 divided by a is 4000. So we get 4000 on the top. And we've got cancellation to do. X on the top, so x squared becomes x. So we get x on the bottom, plus 16x squared, or writing it in exactly the same way we wanted, 16x squared plus 4000 over x, which is just exactly the same as what I've just already got. And there's your third and final mark. Part B said, to minimize the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of A. Minimum value optimization. Let's jump straight in. So part B, I want to optimize the area. To differentiate a function, we need to get it ready. So let's start with our area. We've got 16x squared, but I'm going to have to take that 4,000 x to the minus 1. So I can differentiate it. And you'll actually get a mark straight away there for getting it ready. We now differentiate it. So a dash or a dash x, 2 16s is 32x minus 4,000 x to the minus 2. And that's me differentiated it for a mark as well. So 2 marks out of 6 so far. Now, if we fix that by making it equal to 0, because we're optimizing. So remember, stationary points occur when a dash x, I'll call it, equals 0. So we can say 32x minus 4,000 x to the minus 2 equals 0. For realizing we had to do that and find stationary points, we get another mark. And then we need to solve it. We'll get another mark in a moment for solving it, but I'll show you all the working you need for solving it. So we've got 32x equals 4,000 over x squared, we could say, x to the minus 2. So multiplying through by x squared, we get 32x cubed equals 4,000. Dividing through by 32, 125. So x is the cube root of 125. There's only one answer to that. It is 5. So we now know that x is 5 is our turning point. But we need to prove and show that that is a minimum. We don't know if it's a minimum or a maximum. So we need to do a table of signs. So let's do our table of signs just to show that. X going along 5, and we're going along. A dash x, so a number less than 5, but not 0, because 0 it's undefined. Then if you picked 1, say, you would get 32 minus 4,000 over 1. That's a negative. So we've got negative 0. Hoping that after 5 is positive, but you can check. Just get yourself a calculator, pick a number close to 5. Let's pick 6, say. 32 times 6 is 192. 4,000 divided by 36 is 11. That minus 11 is positive, so we can say it's positive. So our shape is down, along, and up. Therefore, x equals 5 minimizes a. So to get a, remember, for x equal to 5, we work out our area equals 16 times 5 squared plus 4,000 over 5, 1,200 for your final mark. A note on table of signs here. Technically, this is one of those ones where the function is discontinuous. In other words, at 0, because if you can't divide by 0, it breaks. You have to make sure that you have kind of shown that it's in the neighbourhood of 5. I always draw an arrow because the SQA take it to mean a number close to 5, a number close to 5 on either side. If you do that and don't actually say any numbers, you will be fine.
SQA Higher Maths 2024 Paper 1 Question 9. Express log A5 plus log A80 minus 2 log A10 in the form log AK, where k is a positive number or integer. So rules of logs. Log base A of 5 and AA is plus, so 5 times AA. And then I'm dividing by something. Well, let's take that up to the top here. So let's do this one. That's log base A of 10 squared. So divide by 10 squared. So that gives me log base A. 5 8s is 40, so that's 400. 10 10s is 100. That's log base A of 4. I have to leave it in that form, so we're done there. SQA Higher Maths 2022 Paper 1, Question 2. Evaluate 2 log 3x minus log 3, 4. So it's just a 3-mark question, this one. The first one we're going to apply is the idea that 2 log 3, 6 can be simplified to log 3, 6 squared. So you get your first mark for simplifying this first log to log base 3 of 6 squared. And we can still write minus log base 3 of 4. As long as you wrote this, there's your first mark there. And then our second mark for combining the takeaways into one log as a divide. In other words, log base 3 of 6 squared over 4. There's our second mark there. Let's just take a note of that. And of course our third mark for then evaluating what that is, so working it out. So let's do some work on that. Log base 3, 36 over 4 equals log base 3 of 9. Well, 3 squared is 9, so log base 3 of 9 equals 2. And there is our final mark right at the end for getting 2. Just a little note on this. If you did the correct answer but did no working on this question, you would get no marks. You have to show your steps to show that you understood it, otherwise the SQA just thinks you were guessing on this question. SQA Higher Maths 2023 Paper 1, Question 7. Part A, evaluate log 2, 5 plus log 2, 1 over 40. So part A, rules the logs again. Same base with a plus means I can times these two together. So that becomes log 2, 5 times 1 over 40. So that is log base 2 of 5/40ths, which is log base 2 of an eighth, because you can divide by 5. Imagine it as 2 to the power of something as an eighth. Well, 2 to the power of 3 is 8, so 2 to the power minus 3 is an eighth, because it's 1 over 2 to the power of 3. So that means that 2 to the power minus 3 equals an eighth. So this means that the answer is minus 3. Part B. Given A is a member of the real numbers and that log 8a is negative, state the possible values of A. So we're saying that log base 8 of A is negative. So less than 0. We don't need to write the as. So log base 8 of A is less than 0. Let's just think about it logically for a minute. Let's imagine that we did 8 to the power 0, we would get 1. If we take a negative number then, we get 8 to the power of, let's say, negative 2. That's the same as 1 over 8 squared, which is a fraction. And if I take any negative number, 8 to the power of a massive negative number would be a fraction. So it's always going to be either as big as 1 or as small as almost 0. So that means that 0 is less than A is less than 1. We can see this on a graph, I suppose. If I draw a basic log graph, there is 1 there. And below the x-axis is when it's negative. So less than 1 is negative, but only up to 0. It never touches 0. So it's between 0 and 1. So that's another way you could have thought of it. SQA Higher Maths 2023 Paper 1, Question 3. Solve log 5x plus minus log 5/3 equals 2. So rules of logs, if it's a minus with the same base, you can divide these together. So in one step, we get log base 5 of x over 3 equals 2. And then you need to get rid of the log. So remember, it's base to the power of this equals this. So in other words, 5 squared equals x over 3, or to write it nicely, x over 3 equals 25, 5 squared. X divided by 3 equals 25, so that means that x must be 3 times 25, so x equals 75, and we're done there.
SQA Higher Maths 2022 Paper 1 Question 8. Solve log base 6x plus log base 6x plus 5 equals 2 where x is greater than 0. So a couple of different methods you could have used here. So I'll go through the alternatives for you. Let's call this one method 1. And the first method is to combine the two logs. The plus is one single log. So we could write that as log base 6 of x times x plus 5 equals 2. And there's your first mark there. Okay, moving to the second mark, we can write that as 6 squared equals x times x plus 5, or x times x plus 5 equals 6. So there's our second mark there. And then we can move on to try and solve that as a quadratic equation. So standard quadratic way, multiply out the brackets, we get x squared plus 5x, and that equals 36. So tidying that up, minus 36 equals 0. There's our third mark there for putting it in the proper quadratic form. And then our fourth mark, try to solve that. Double brackets, x and x, 9 and 4 times together to make 36, but take away make 5. So we've got plus 9 minus 4. So x equals 4 or x equals minus 9. But x has to be greater than 0 because it says so in the question. So we disregard one of the answers. So since x is greater than 0, x equals 4 is the only valid answer. And there is our final mark right there. We have to have stated that x equals 4. We disregarded the minus 9 to get that final mark. Let's look at method 2. So method 2 starts the same way. We apply the same rule as before. So we write log base 6 of x bracket x plus 5 equals 2. And we get our first mark. The log base 6 of x plus 5 equals the log base 6 of 6 squares. Because remember, log base 6 of 6 is 1, so that is 2. And that would give us our second mark. And then we can cancel the logs from both sides to just write x plus 5 equals 6 squared, or x squared plus 5x equals 36. And it continues in the same way as the last method. Minus 36 is 0. There's our other mark. And then for our final mark, solving that equation, we get x and x, 9 and 4, plus 9 minus 4 equals 0. So x equals 4 or x equals minus 9. But since x is greater than 0, x equals 4 is the answer. And there's our final mark there for 4 marks.
SQA Higher Maths 2024 Paper 2 Question 11. The number of electric vehicles worldwide can be modelled by n equals 6.8 e to the kt, where n is the estimated number of vehicles in millions. Watch out for that word. T is the number of years since the end of 2020, and k is a constant. Use the model to estimate the number of vehicles worldwide at the end of 2020. So at the end of 2020, t equals 0. So you get n equals 6.8 times e to the 0, which is 1. So that's 6.8, but it's not 6.8. 6.8 million. You'll probably lose a mark if you miss that word because it's not 6.8. Part B. At the end of 2030 is estimated at 125 million electric vehicles worldwide. Determine the value of k. So we want n is 125 million, 125 equals 6.8 e to the power of, and k, t. So t, 30, 20, 10 years, 10k. So that's a logarithmic equation. It's going to turn it. We're going to use logs because it's an exponential. So divide by 6.8. That equals e to the 10k. Take the natural log of both sides. ln, I'll write 1025 over 6.8 equals ln e to the 10k. 10k can come down to the front to get ln e, which is just 1, remember. And that is ln 125 over 6.8. And therefore, k is very simply ln 125 over 6.8, all divided by 10, which is a calculator job. ln 125 over 6.8, all divided by 10, 0.2911, blah, blah, blah. I think 291 is fine, 0.291, and that's k. Have we answered the question? Yes. So we're done there. 10. The heptathlon was an athletics contest made of 7 events. Athletes score points for each event. In the 200 metres event, points are calculated using this formula, where P is the number of points and T is the athlete's time in seconds. Calculate how many points are awarded for a time of 24.55 seconds in the 200 metres event. So we just need to substitute 24.55 in for T. So we've got P equals 4.99087, 42.5 minus 24.55 to the power of 181. That's 4.99087 times 17.95 to the power of 1.81. 929.0368. Let's just make that 929.04. It doesn't quite specify whether the points are whole numbers or not, so that seems reasonable given the accuracy of the rest of the question. Right, in the part B, in the long jump event, points are calculated using this formula, where P is the points, D is the distance in centimetres, and K is a constant. It says 850 points are awarded for a jump of 600, calculate K, so we'll just substitute in and work from there. So we've got P, which is 850, equals 0.188807. D is 600, minus 210 to the power of K. So 850 equals 0.188807, 390 to the K. So dividing through, we get 850 over 0.188807 equals 390 to the power of K. Logging both sides, I'll just use the natural log. Taking the K to the front then. Equals log of 850 over 0.188807 divided by the log of 390. So it's time to get a calculator to work these out. 1.40999, so K equals 1.41. SQA Higher Maths 2023, Paper 1, Question 9. The diagram shows the graph of function f of x is log base 3x. X is greater than 0, of course. The inverse function does exist. In the diagram in your answer book, draw the graph of the inverse function minus 1. Well, let's examine the inverse function first. The inverse function of a log is an exponential. And essentially, the easiest way to draw it, imagine a dotted line here, y equals x. The coordinates just switch places, okay? So here is my normal y equals x. So 1, 0 becomes 0, 1. And 3, 1 becomes 1, 3. and it just gives you an exponential curve. And that would be 1, 3. So that's the inverse function of x. So now I just need to take away 1, which means just to move it down by 1. So 1 is going to go to 0, and 1, 3 is going to go to 1, 2. So I can just draw it now. There's 0. It's obviously going to drop below because that's where your asymptote is, essentially. So it's going to go along up through 0 and start climbing. And we just put that point on that we noted, which was 1, 3. So it now becomes still 1, but 2, and we're done there.
Solving logarithmic equations, SQA Higher Maths 2018, paper 1, question 11. Diagram shows log 3x. On the diagram in the answer book, sketch the curve of equation 1 minus log 3x, and then find the point of intersection between the curves, which will be solved with logarithmic equations. So 1 minus log 3x, the minus part here tells me to reflect in the x-axis, and then the 1 part, which I'll do in another colour here, tells me to then move up by 1. So first of all, reflecting in the x-axis, this point will stay where it is, but this point will jump down here, and that would be at the moment as in point 3 minus 1. But now I have to move up by 1, so this point is going to jump up by 1, so that becomes 1, 1. And you can see this point goes up to 3, 0. So I can just write the number 3 here. Getting rid of my intermediate working, which you could use a rubber if you were doing this by hand. And since it's reflected, it's going to go down and through here. So we can just draw that in, down here, through the way, and there we go. It's a reflection in the x-axis. Okay, part B, determine the exact value of the point of intersection, simultaneous equations. So for part B, we've got y equals log 3x, but we've also got y equals 1 minus log 3x. So we can say that they are equal to each other and find x. So log 3x equals 1 minus log 3x. So taking the log 3x to the other side, you'll have log 3x plus log 3x. So 2 of them, 2 log 3x equals 1. I can take the 2 up as a power, so I get log 3x squared equals 1. Now I've got it in the form log of something equals a number, so 3 to the power of 1 equals x squared. 3 to the power of 1 equals x squared, and therefore I can find x. X equals 3 to the power of a half, or x equals the square root of 3. And we're done there. Notice it'll only be the positive part of this instead of the negative part, because if x was negative, then you'd have log of a negative number, which doesn't exist, so it's just a positive. I can take a note of that. Just positive value, as x has to be greater than 0. Relation from a straight line for logarithmic graphs. SQA Higher Maths 2019, paper 2, question 12. Two variables x and y are connected by the equation, and this is what you're looking for. Y equals ab to the x, a power. And we're looking at one of the axes is logged, but the other one is not. So it's only one log this time. But always start from your equation and get the logs coming out and see where you go. So I'll start with y equals ab to the x. We'll have to find the values of a and b. So let's start with y equals ab to the x. Just log both sides then. Our log base is 4. So looking on our graph, log base 4y equals log base 4 of ab to the x, which is a product. So I can separate that into a plus. So log base 4y equals log base 4 of b to the x. I like the x one first, like mx plus c, plus log base 4a. Taking the x to the front, we get log base 4y. That's a y and that's a log. Equals x times log base 4b plus log base 4a. Well, y equals mx plus c is a straight line, so let's put the x on the end so you can really see it. Log base 4y equals log base 4b times x plus log base 4a. So that's like y equals mx plus c. So we can see our gradient is equal to this number in front of x, and our c is equal to this. So we can say our gradient is equal to log 4b. So let's just check our graph to see if we can work out the gradient. We're given 2 points, so our gradient is equal to y2 minus y1 over x2 minus x1. So that's 8 minus minus 1 over 3 minus 0. That's 9 over 3, which is 3. So we know our gradient's 3, so log base 4b equals 3. Remember, that means that 4 to the power of 3 equals b. 4 cubed is b. 4 cubed is 64, and therefore b equals 64. Now let's try our c. From the work we've just done, our c is equal to log base 4 of a. C is where it cuts the y-axis. We know it cuts the y-axis at 0, minus 1, so c is minus 1. So we can just straight away say that minus 1 is equal to log base 4 of a, or if you prefer, log base 4a equals minus 1. Remember, that means 4 to the power of minus 1 equals a. You can just write that straight away. 4 to the minus 1 equals a. 4 to the power of minus 1 is 1 over 4 to the power of 1. So therefore, a equals 1/4. And we're done.
SQA Higher Maths 2024, paper 2, question 6. Two variables x and y are connected by the equation y equals ax b. The graph of log 5y and log 5x are shown, and it's a straight line. So we've got log 5y by log 5x, and find a and b. Right, so I always usually start with the equation. Some people skip ahead, but I don't like to. So I'll start with that, and I log both sides. The base is 5. Log base 5y equals log base 5 ax to the b. So now I can separate my log out on the right hand side to log base 5a plus log base 5x to the b. So that means log base 5y equals log base 5a plus b comes out the front, log base 5x. And put that in a kind of form of y equals mx plus c. You've got your log base 5y. I'll take the x bit first. So b times log base 5x plus log base 5a. So now just comparing your graph, your y-axis is log base 5y, so that's like your y, and your x-axis is log base 5x, so that's like your x. So that bit there is your gradient, mx, and that bit there is your c. So the gradient is b. So what's the gradient of this line? Well, I've got 2 points, 0, minus 2, and 410. So the gradient between 0, minus 2 and 410 is what we're going to do. So my gradient equals 10 minus minus 2, 4 minus 0, that's 12 over 4, that's 3. So that means that to answer the question, b equals 3. Now it says find c. Well, I already know where it cuts the y-axis, 0, minus 2. So that's it, c is minus 2. So if c is minus 2, that means that log 5a equals minus 2. So that means that 5 to the power of minus 2 equals a. That's 1 over 5 squared. 5 squared is 25, so a is 1/25. And we've got that, so we're done. SQA Higher Maths 2024, paper 1, question 10. Show that x minus 1 is a factor of that, and then factorise it fully. We're just going to use synthetic division. 2, 3, minus 4, minus 3, 2. Put in 1 in. We get 2, 2 ones is 2, plus is 5, that's 5, 5 minus 4 is 1, that's 1, 1 minus 3 is minus 2, that's minus 2, and we get 0. We just say remainder 0. So x minus 1 is a factor. So now we have to factorise it fully. So for part B, we've now got x minus 1 times 2x cubed plus 5x squared plus x minus 2. So I need to find another factor. Now I've already got minus 1, so I could try 1, I could try 2 or minus 2. or I could try any multiple of 2 times 2 is 4, any factor. Now I'm going to try, I've already done this to be fair with you, and I got it on 1. But you just keep trying numbers till it works. If you can't do it, I've got 2, 5, 1 and minus 2. And I know that minus 2 is going to, does work. So I get 2, 2 2s is 4, 5 minus 4 is 1, that's minus 2, plus 1 is minus 1, that's 2, that's 0. So again, remainder 0. That means that x minus plus 2 is a factor, because I put in minus 2. So then we can continue to factorise. X minus 1, x plus 2, and 2x squared plus x minus 1. So just check if that's factorisable. You can either see it or you can just check in some other way. But I can see it as factorisable. 2x and x. 2 ones is 2, and then 1. So I want plus 2 minus 1. 2x squared plus 2x minus 1x is x. Minus 1 times 1 is 1 minus 1, so we're done there. SQA Higher Maths 2023 paper 1 question 10. Show that x plus 5 is a factor of this, and it's a 4th power one, and then hence or otherwise solve it equal to 0. So usually we do cubics, but 4th powers can come up. So you're going to show it's a factor, you're going to end up with a cubic, and you're going to have to then start with a cubic by just guess and check to find another factor. So let's start off showing it's a factor. Easiest way is using synthetic division. So x plus 5 is a factor, so I'm subbing in minus 5. So it's 1x to the 4 plus 3x to the cubed minus 7x squared plus 9x minus 30. So we drop the 1 down, times them together to get minus 5. Minus 5 plus 3 is minus 2. Times it by minus 5 again, you get 10. 10 minus 7 is 3. Times by minus 5 again to get minus 15. Minus 15 plus 9 is minus 6. Times it by minus 5 again to get 30. 30 minus 30 is 0. 2 options for your statement. You could write f of minus 5 equals 0, and therefore x plus 5 is a factor. Or the alternative is just writing since the remainder is 0, x plus 5 is a factor. Either of the options are fine, but you need to write a statement. Hence or otherwise solve the equation. So part B, we now know that it becomes x plus 5. Then you've got x cubed minus 2x squared plus 3x minus 6 equals 0. We're going to have to check numbers here to find another factor. So the easiest way is direct substitution. So if I try 1, we're going to get 1 cubed minus 2 times 1 squared plus 3 times 1 minus 6. 1 cubed is 1. Minus 2 is minus 1. Minus 1 plus 3 is 2 minus 6 is minus 4. So it's not that one. Try minus 1. You get minus 1 cubed minus 2 times minus 1 squared plus 3 times minus 1 minus 6. Minus 1 cubed is minus 1. Minus 2 is minus 3. Minus 3 is minus 6. Minus 6 is minus 12. So it's not that one. So then you would try 2, and you're just doing it systematically. Once you get bigger, you can go back to synthetic division. I'll stick with this for 2, because it's quite simple. 2 cubed minus 2 times 2 squared plus 3 times 2 minus 6. That's 8. 2 2s are 4 times 2 is 8. Plus 6 minus 6, that's 0. Therefore, we've got another factor of x minus 2. So we're going to have to synthetic division it anyway, but we now know 2 goes in. So synthetic division just on the x cubed minus 3x squared plus 3x minus 6. 1x cubed minus 2x squared plus 3x minus 6. And we're subbing in 2. Now you could have just done that to the start and done it for 1, minus 1, 2 and so on. We've got 1, 2 ones are 2, minus 2 is 0, 0 again, plus 3, 3 2s are 6, get 0. So because since f of 2 equals 0, x minus 2 is a factor. Or since the remainder is 0. At this stage, you don't have to show that it's a factor, so you don't really have to need the statement, but just to be on the safe side. So we've got x plus 3 still, x plus 5 still, sorry, and then x minus 2. So that implies our original function, which is x4 plus 3x cubed minus 7x squared plus 9x minus 30 equals 0 becomes x plus 5, x minus 2, and then we've got, this has become a quadratic, x squared plus 0x plus 3, and that equals 0. Now we need to solve it, so each factor becomes equal to 0, so that implies that x plus 5 equals 0, or x minus 2 equals 0, or we could say x plus 3 equals 0. The first one gives us x equals minus 5, second x equals 2, and this one, no solutions, because if you take it over to the other side, you get x squared equals minus 3, and you can't square a negative number. SQA Higher Maths 2024, paper 2, question 13. The diagram shows the graph of y equals f of x, which is a quartic function. How interesting. So, express f of x in the form k x plus a squared x plus bx plus c. Okay, so how you go about this is, those are roots, and roots can turn into factors. So, when x equals minus 1, the factor is x plus 1. Similarly, when x equals 3, our factor is x minus 3. But that's a turning point, and if a turning point is a root, that means that one's squared. And then when x equals 5, our factor is x minus 5. So we've straight away got f of x, and I'm going to write these in order. The order is written here, k. X plus a squared, x minus 3 squared, x plus b. So the next one I come to is minus 5 and plus 1, or plus 1 and minus 5. It really doesn't matter, does it? What we got? Nah, it doesn't really matter at all. So I'll just put them in the order, x plus 1 and x minus 5. The order that we appear is roots, minus 1 and 5. So we've still got a k in the way, but we've got a point, 0 minus 9. So you just sub that in. When x equals 0, y, which is f of x, is minus 9. So that means we've got minus 9 equals k, minus 3 squared, 0 minus 3, 1, and minus 5. 0 plus 1 is 0 minus 5. So minus 9 equals k times 9 times 1 times minus 5. So minus 9 equals 9 5s is 45, minus 45k. So k is minus 9 over minus 45. 9 is a common factor, so that's 1. 9 5s is 45, that's a fifth. Finally, answer the question. F of x is equal to 1/5 of x minus 3 whole squared, x plus 1, and x minus 5. And we're done there. SQA Higher Maths 2016, paper 1, question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the point 19 to work out our k. X equals 1, y equals 9. So we get 9 equals 1, k times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3,
1 plus 5 is 6. 6 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5, remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so d must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write d is greater than 9, and we're done there.
Unusual question, SQA Higher Maths 2018, paper 1, question 15. A cubic function is defined a set of real numbers. X plus 4 is a factor, x equals 2 is a root, f dash minus 2 equals 0, and f dash x is greater than 0 when the graph crosses the y-axis. X plus 4 is a factor, means that x equals minus 4 is a root. That's where it crosses the x-axis. X equals 2 is a repeated root, which means that it's also a turning point on the x-axis. That's what happens when you've got a repeated root. So we can start drawing a graph. We can look at the other options in a minute. But if we draw a y and x-axis, just a quick sketch, we've got minus 4 as one of our roots, and we've got 2 is, I'll just put it here actually, as another root. And when looking at our derivatives, f dash of minus 2 equals 0. So we now know that at minus 2 at some point, we've got a turning point as well, not on the x-axis, but then we also know that f dash x is greater than 0 when it crosses the y-axis. So we know that it's going up at this point, but this is a turning point, so it must drop back down. So we now know that it must go like this. And we know that this is a turning point, so it must turn here and go up here because that's a root. So we've got a root, a repeated root, and we're done there. SQA Higher Maths 2018, paper 2, question 4. Express minus 3x squared minus 6x plus 7 and ax plus b squared plus c. So completing the square on this. So we take our function and we take the common factor out, which is minus 3 of the first two terms. So that gives us minus 3. We've got x squared then plus 2x, because minus 3 times 2 is 6x, and then we've still got a plus 7 on the end. So completing the square on this bit, we get minus 3, half the term, so x plus 1 all squared, and take away 1 squared, 1 times 1. And then we've still got plus 7, so that gives me minus 3, x plus 1 squared minus 1 plus 7, and then expanding that bracket, that's minus 3x plus 1 squared. 3 times 1 is 3, it's minus times a minus, so it's plus 3 plus 7. And then finally, our final answer, minus 3, x plus 1 squared plus 10. And we're done there. Increasing and decreasing functions, SQA Higher Maths 2019, paper 2, question 7. Express this in the form p x plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2's is 4, 4 6's is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increase or decrease, we need to evaluate the gradient of the tangent, in other words, differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it. But notice that is minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here and I square it, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there.
Okay, completing the square. SQA Higher Maths 2015, Paper 2, Question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x, plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13, plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1, x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1, x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we've just completed the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there.
SQA Higher Maths 2024 Paper 1 Question 8. The equation x squared plus m minus 4x plus 2m minus 3 has no real roots. Determine the range of values for m. So if it's got no real roots, that means that b squared minus 4ac must be less than 0. So a is equal to 1, b is m minus 4, and c is 2m minus 3. So we're just going to sub that in. So we've got m minus 4 squared minus 4 times 1 times 2m minus 3, and that's less than 0. So that's m squared minus 8m plus 16, take your time expanding. 4 times 1 is 4, times 2 is 8, so minus 8m. And then minus times a minus is a plus, so plus 12, less than 0. So that gives me m squared minus 16m, and then plus 28 is less than 0. So this is a quadratic inequality. So what we do with these is we look at the roots and draw a little graph. So the roots, we've got double brackets, m and m. And for the roots, we've got 14 and 2. Minus 14 minus 2 is minus 16. 14 2s is 28. So we get m equal 2 and m equal 14 as our roots. So we now draw a graph. Just a rough one. There's 14. There's 2. There's your quadratic. It was positive, yep. And we want it less than 0. So underneath here, that's between these two numbers. So our final answer is 2 is less than m is less than 14. And we're done there. SQA Higher Maths 2019, Paper 1, Question 2. The equation x squared plus k minus 5x plus 1 has equal roots. Determine the values, possible values of k. Well, if it's got equal roots, that means that we write for equal roots. That implies b squared minus 4ac equals 0. So our a is the number in front of x squared. Our b is k minus 5, the number in front of x. And our c is just 1. So for b squared minus 4ac, we get k minus 5 squared minus 4 times 1 for a times 1 for c equals 0. Expanding k minus 5 all squared gives me k squared. Minus 5 times 2 is minus 10, so minus 10k. 5 5s is 25. And then we've got 4 times 1 is 4 equals 0. So that's k squared minus 10k. 25 minus 4 is 21 equals 0. And if we're lucky, that will factorise. So we've got k and k. 7 3s is 21 and 7 and 3 make 10. So it's definitely 7 and 3. Minus 7 minus 3 is minus 10. So k equals 3 or k equals 7. And we're done there. Permanent SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has two real and distinct roots. Determine the range of values for m. So two real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is the number in front of x squared, which is 1. Our b is the number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared
minus 6m plus 9. And then 4 times 1 is 4 times m, so minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Okay, looking at quadratic inequalities, SQA Higher Maths 2015, Paper 1, Question 8. ABCD is a rectangle with lengths x and x minus 2 as shown. If the area is less than 15, determine the range of values of x. Well, area is length times height. So I'll just write that down, or length times breadth if you prefer. So our length is x, and that's x minus 2. And it says that that area has to be less than 15. So I'll just write x minus 2 is less than 15 to set up my inequality. Expanding my brackets, I get x squared minus 2x is less than 15. I've got a quadratic, so I need to take the 15 to the other side. And we need to then find out the roots and draw a graph to see where it's less than 0. So looking at the roots of this, we've got x squared minus 2x minus 15. If that's factorizable, hopefully, we get x and x, 5 and 3. Minus 5 plus 3 is minus 2, so roots are x equal to minus 3 or x equal to 5. So that means we can draw a quick sketch at the side. Minus 3 is over here, and 5 is over here somewhere. It's positive x squared, so our quadratic looks something like that, and it just has to be a quick sketch. Now we're looking to see where it's less than 0. Well, it's less than 0 below the x-axis, so that is in between these two numbers. Minus 3 is less than x is less than 5. But we need to be careful with this question because it is about the area of a rectangle, so we can't have a negative length. X must be, let's have a look. We've got x minus 2 is our smallest, so it has to be bigger than 2. Or the breadth would be negative. And therefore, our actual answer is 2 is less than x is less than 5. Need to be very careful with ones where it's in context.
SQA Higher Maths Paper 1 Question 3. Circle C1 has this equation and C2 has centre 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of circle C2. So we have got our equation up here, and just remember from our equation x squared plus y squared minus 2x minus 2y minus 26 equals 0. You're given at the start of the exam paper the radius. The radius is quoted as equaling the square root of g squared plus f squared minus c. And your g and your f, well, this is called 2g and 2f. So 2g is minus 6 and 2f is minus 2. So my g is minus 3 and my f is minus 1. So my radius is equal to minus 3 squared plus minus 1 squared. Take away c, but it's a minus already, so plus 26. So that means that going down here, my radius is equal to the square root of 9 plus 1 plus 26. That's the square root of 36, which is equal to 6. So we've got our radius, and we know the circle centre is 4 minus 2. So we know the equation of C2 must equal x minus 4 squared plus y plus 2 squared equals 36. And we're done there. SQA Higher Maths 2016 Paper 1 Question 4 on the circle. A and B are points 7, minus 3 and 1, 5. Let's just take a note of that. So there's A, minus 7, 3, and B is 1, 5. Find the equation of a circle. So for the equation of a circle, we need two things. We need the centre and the radius. So where's the centre? It's in the middle of these 2 points. So the midpoint of A and B, let's just call that midpoint of A and B. We add the x parts, minus 7 plus 1 over 2. We add the y parts, 3 plus 5 over 2. Minus 7 plus 1 is minus 6, divided by 2 is minus 3. And 3 plus 5 is 8, divided by 2 is 4. So we've got a midpoint. We now need our radius. So to get our radius, we use the distance formula. So we now know we've got minus 3 and 4. So the distance, let's just call this m. The distance between m and say b is Pythagoras, the square root of minus 3 minus 1 squared plus 4 minus 5 squared, or the other way round. That's the square root of minus 4 squared plus minus 1 squared. That's the square root of 16 plus 1 is 17. So the distance is 17. So now using the start of our exam paper, x minus a squared plus y minus b squared equals r squared. So our centre is minus 3, 4. So that's x plus 3 squared plus y minus 4 squared equals root 17 squared, which is just 17. And we're done there. SQA Higher Maths 2018, Paper 1, Question 4. The point K lies on the circle with this equation. Find the equation of a tangent to the circle at K. Tangent meets a radius at right angles. So we need to find the centre of our circle. So we've got it in expanded form. So from the start of the exam paper, we are told that x squared plus y squared plus 2gx plus 2fx plus c equals 0 is the equation of a circle, where the centre is equal to minus g minus f, and the radius is equal to the square root of g squared plus f squared minus c. So looking up at our equation, the number in front of f, 2g, is minus 12, and the number in front of y, 2f, is minus 6. So that gives me g is minus 12 divided by 2, minus 6, and it gives me f is minus 6 divided by 2, minus 3. So our centre is just simply 6, 3. Once we've got our centre, we can find the gradient between our centre. Let's just call our centre C. So the gradient between C and K is minus 5 take away 3 on the top and 8 take away 6 on the bottom. Minus 5 take away 3 is minus 8 over 2, which is minus 4. So the gradient of our perpendicular equals a quarter, since m1 times m2 equals minus 1. So our point is 8 minus 5 for K. So we can use y minus b, y plus 5 equals m x minus a, which is 8. Times it through by 4, we get 4 times y plus 5 equals x minus 8. So 4y plus 20 is x minus 8, or to leave it in a nice way, 4y minus x equals minus 28 would be a fine answer. If you prefer y equals, you can divide through by 4 to get y equals a quarter of x, and then minus 28 divided by 4 is minus 7 if you prefer. SQA Higher Maths 2015 Paper 1 Question 11 for the equation of a tangent to a curve. Question 11 says the point t minus 2 minus 5 lies in the circumference of the circle with this equation. Find the equation of the tangent to the circle through t. For part A, so the part A is a circle question, and part B says the tangent is also a tangent to a parabola with that equation to determine the value of p. So let's do part A, circles. The centre of our circle is just minus 8, minus 2. Minus 8 and minus 2. And we've also got our point T, which is minus 2, minus 5. So if we work out our gradient, if we draw a circle for this, there's our C, there's our T, say, out here. That meets the tangent at right angles. So the gradient between C and T is perpendicular to the tangent. So the gradient of CT is equal to minus 5 minus minus 2 over minus 2 minus minus 8. Minus 5 add 2 is minus 3. Minus 2 add 8 is 6. That's equal to minus a half. Therefore, the gradient of the tangent is 2, since m1 times m2 equals minus 1. And then our point, remember, is minus 2 minus 5, so y minus minus 5 equals 2x minus minus 2. So y plus 5 equals 2x plus 4, or y equals 2x minus 1. And we've got the equation of our tangent. Part B says the tangent is also a tangent to a parabola of equation y equals minus 2x squared plus px plus 1 minus p, where p is bigger than 3. Find the value of p. Well, if it's a tangent to that parabola, it means that y equals 2x minus 1 goes into this, so we can just equate them in simultaneous equations. So we can just say that 2x minus 1 equals minus 2x squared plus px plus 1 minus p, and solve that equation to get our x. So moving everything over to the left, we get 2x squared because it's negative. We've got plus 2x, then minus px, and then we've got minus 1 minus another 1, but then plus p, and that would equal 0. Equating all our terms, so we get an x squared, x and a number. You get 2x squared. We can factorise x out here, so we've just got x, so it's 2 minus p times x. And then we've got minus 2 plus p equals 0. So we've got a quadratic, but when you get a quadratic, it only has one solution on it, only touches at one point when the discriminant equals 0. So tangent, therefore b squared minus 4ac equals 0. So our b is 2 minus p, so 2 minus p squared minus 4 times a times c, which is minus 2 add p, equals 0. Multiplying that out, 2 2s is 4, minus 2 times p is 2p, so minus 4p plus p squared. And then you've got 4 times 2 is 8, so it's minus 8 times minus 2 plus p. So you get 4 minus 4p plus p squared plus 16 minus 8p equals 0. So p squared, and then our p terms, we've got a minus 8 minus 4 is minus 12p, and then our constant terms, 16 plus 4 is 20, equals 0. So we've got a quadratic to solve it. We can now factorise, hopefully. If that equals 0, then we get p and p. 10 and 2 to make 12 in the middle, and it'll be minus 10 and minus 2. So p equals 2 or p equals 10. But if you go back to the original question, it says p is greater than 3. So we can disregard that one. So p equals 10 as our final answer. SQA Higher Maths 2024, Paper 1, Question 7. The line y equals 2x is a tangent to the circle x squared plus y squared minus 14x minus 8y plus 45. Find the coordinates of the point of contact. Well, finding the point of intersection means solving simultaneous equations, so I'm just going to sub it in. So I've got x squared plus y squared, which is 2x, minus 14x, minus 8y, so it's 8 times 2x, plus 45 equals 0. And we'll just solve that for x. So that's x squared plus 4x squared minus 14x minus 16x plus 45. That's 5x squared, and that's minus 30x, and that's 45. So 5 is a common factor. X squared minus 6x plus 9. Remember, this is a tangent, so if you get more than one answer, you've made a mistake here. So watch out. You could just completely square, but I can see here that I can just factorise it. Half the term, that's 3 and 3, minus minus. Minus is a minus is a plus, that's plus 9. Minus 3 is minus 6. So you get x equals 3 as your x coordinate, and therefore y equals 2 times 3, 2x, which is 6. So your point of contact is 3, 6, and we're done there. The intersection of lines and circles again. The line 3x intersects the circle with equation x minus 2 squared plus y minus 1 squared equals 25. Find the coordinates of the point of intersection. So if they intersect, it means we're solving them simultaneously to see these points. So y equals 3x is our first equation. And when we'll write down our circle equation, x minus 2 squared plus y minus 1 squared equals 25. So to solve these simultaneously, we use substitution. We know that y is 3x, so we'll replace the y with 3x in this equation. So we've got x minus 2 squared plus 3x minus 1 squared equals 25. Multiplying out our brackets to get a quadratic then, we've got x squared minus 4x plus 4 for the first bracket, and then we've got 3 3s is 9x squared, 3 1s is 3, double that is 6, so minus 6x plus 1. And then I'll just take away 25 and make it equal to 0 because I'm going to get a quadratic. If you're struggling with multiplying out these brackets, you can just take your time and multiply them out any way you want. So we've got x squared and 9x squared is 10x squared minus 10x. 4 plus 1 is 5 minus 25 is negative 20 equals 0. 10 is a common factor. X squared minus x minus 2. So 10, hopefully it's factorisable. 2 and 1. We want to get minus 1, so it's minus 2 plus 1 is minus 1. Minus 2 times 1 is minus 2. So x equals minus 1 or x equals 2. We've got our x point, now we need to get our y point. So when y equals 3x, at x equal to minus 1, y equals minus 3. The point is minus 1 minus 3. And for y equal to 3x, when x equals 2, y equals 6. So our point is 2, 6. There's our 2 points of contact. And we're done there.
SQA Higher Maths 2023, paper 2, question 15. The last one, the line x plus 3y equals 17 is a tangent to a circle at the point 2, 5. And it also says the centre of a circle lies on the y-axis. So if we imagine this is a y-axis here, somewhere that centre is on that y-axis. So now it asks us to find the coordinates of the centre of the circle. Actually, quite a tricky one, this one, but let's just start dealing with it. Where's our centre here? We know that the radius meets the tangent at right angles. So if I knew the gradient here, I would automatically know this. So let's start on that point. We've got x plus 3y equals 17. 3y then equals minus x plus 17. Y equals minus a third of x plus 17 over 3. The gradient of that is minus a third, and therefore the gradient of the perpendicular is equal to 3 because m1 times m2 equals minus 1. We also know that the centre of the circle lies on the y-axis. So if it lies on the y-axis, it goes along 0. So if I draw an x-axis in, we don't know where this x-axis is, so I'm not going to put it there. That's like our x-axis. It goes along 0 and up some number, call it c. But we know our gradient is 3, and we've got 2 points, so we can use the gradient formula and work out our c. So let's just do that. We've got 0c, and we've got 2, 5. So y2 minus y1, 5 minus c equals 2 over 2 minus 0 equals our gradient of 3. So we've got 5 minus c over 2 equals 3. 5 minus c equals 6. So I'll just take the 5 over. Minus c equals 6 minus 5. 6 plus 5. Minus c equals 6 minus 5, which is 1. So c equals minus 1. So the centre of the circle is simply 0 minus 1. And we're done there.
Okay, SQA Higher Maths 2016, Paper 1, Question 8, the intersection of lines and circles this time. Show that the line with equation y equals 3x minus 5 is a tangent to the circle with this equation and find the coordinates of the point of contact. So if it is a tangent, it means this y is equal to the y in here. So I can substitute this into this equation. So I've got x squared plus 3x minus 5 squared plus 2x minus 4 times 3x minus 5 equals 0. So multiplying out our brackets, we get x squared plus 3 3s are 9, so 9x squared. 3 5s is 15 times 2 is 30, so minus 30x plus 25 plus 2x. 4 3s is 12, so minus 12x. 4 5s is 20, so plus 20, then minus 5 equals 0. So you're going to get a quadratic. So we've got x squared plus 9x squared is 10x squared. Minus 30x plus 2x is minus 28x. Minus 12x is minus 40x. And then we've got our number part, 25 plus 20 is 45 minus 5 is 40. And we know that that equals 0. So we can solve that by taking 10 out as a common factor to get x squared minus 4x plus 4 equals 0. And then let's solve it. Now we're looking if it's a tangent for only one solution because it only touches it at one point. So this should be equal roots. So let's check x and x. 2 2s is 4, so minus 2 equals 0. So we can say that it's got equal roots. So only one point of contact. Therefore, the line is a tangent to the circle. Find the coordinates of the point of contact. Well, we've already got this equation equal to 0, so that implies that x equals 2. And then subbing that back in to get a y, well, we might as well just use our original equation, y equals 3x minus 5. So we've got y equals 3 times 2 minus 5. 6 minus 5 is 1, so we've got 1 and 2. So our point of contact is 2, 1. And we're done there. SQA Higher Maths 2024, Paper 1, Question 13. P and Q are the points 4, 10, 6, 2, and find the equation of the perpendicular bisector of PQ. So there's PQ there. Perpendicular bisector means it cuts it in half at right angles, as you can see. So I need the midpoint. So for part A, I need the mid of PQ. Well, that is 4 plus 6 over 2 and 10 plus 2 over 2. 4 plus 6 is 10, divided by 2 is 5, and 10 plus 2 is 12, divided by 2 is 6. So I've got my midpoint, and now I need the gradient. Well, it's perpendicular, so I can find the gradient of PQ and use m1 times m2 is minus 1. So y2 minus y1, so it's 2 take away 10, all over 6 take away 4. 2 take away 10 is minus 8, 6 take away 4 is 2, so that gives me minus 4. So that means the gradient of the perpendicular equals 1/4, and I need to say why I know that. m1, m2 equals minus 1. So now I can do my equation. Y minus b, that's 6, 1/4, x minus 5. Take the 4 up to the other side and get x minus 5 on this side. So that's got 4y minus 24 is x minus 5. Leave it in any form you want, but I'm going to do 4y minus x and just take a 5 over. minus 24 plus 5 is minus 19, and that'll equal 0. And that'll be fine for that one. R has coordinates 12, 2. The circle passes through points P, Q, R, and QR is a horizontal chord. It's horizontal. So if you imagine this is also a chord, and this is the diameter of the circle. Should be obvious that's the diameter because it's cutting a chord in right angles and at half. So that is definitely the diameter. So there's our centre of our circle there. Let's call that C. Now if I was to drop that down at right angles and cutting that in half, that means that I would have the x part of the coordinate, and I can just sub in my equation and get the y part to get the centre. So that's what I'm going to do. The mid of QR. So part B, the mid of QR is equal to, we've got 6, 2 and 12, 2. So 6 plus 12 divided by 2 and 2 plus 2 divided by 2. 6 plus 12 is 18, divided by 2 is 9, so we get 9, 2. So when x equals 9, that's going to be for our centre, we get 4y minus x, which is 9 minus 19 equals 0. So 4y minus 28 must equal 0. So y is 28, not 4y is, stupid. So that means y is 28 divided by 4, which is 7. So we now know our centre is equal to 9 and 7. Now what about our radius? Well, there's 9, 7 there. Just use a point on the outside. Let's just use this one to get our radius. So the radius is 410 to 97, the distance. So for our radius, which we'll just do squared, I'm going to use 410 and I'm going to use the centre 97. So distance between 9 and 4, so 9 minus 4 squared. And the distance between 7 and 10, 7 minus 10 squared, or 10 minus 7. I'm just going to do it squared because I'm going to use keep it as r squared anyway. 9 minus 4 is 5 squared. 7 minus 10 is minus 3 squared. So r squared is 25 plus 9, which is 34. So that means now we've got our radius squared and our centre was 9, 7. So the equation of the circle is x minus 9 squared plus y minus 7 squared equals 34. And we're done there. For paper 2, question 10, circle C1 has the equation x squared plus y squared plus 18x minus 2y minus 8 minus equals 0. Find the radius and centre. So start the exam paper for this. Usually for part A, I'll just do it here actually. You would say 2g equals the number in front of x, 18, and 2f equals the number in front of y minus 2. So g is 9 and f is minus 1. And from the start of the exam paper, the centre is minus g minus f. So that is equal to minus 9 and 1. Now we want our radius. So from the start of the exam paper, the radius is the square root of g squared plus f squared minus c. I usually remember it like this. The square root of the centre numbers added together, take away the last number. So minus 9 squared and plus 1 squared and minus 8, so plus 8. So that equals the square root of 9 nines are 81, 1 ones are 1, plus 8. 81 plus 1 is 82, plus 8 is 90. All surds should be simplified in higher maths. Root 9 root 10. That's 3 root 10. So there's our radius. And there's our centre. And we're done there. Part B says, the second circle C2 touches C1 internally. The centre of C2 is minus 6, 0. Determine the equation of C2. Well, there's our new centre for this big circle, minus 9, 1. Now, if you imagine taking the centre of this and the centre of that, if I did this big one minus that one, it leaves me what's in between, which is, well, the distance between the centres. So we can use that fact quite handily, that the radius of the big one minus the radius of the small one equals the distance between the centres. We're going to say that R2 minus R1 equals D because they touch internally. So we already know R2, it's 3 root 10. We don't know R1, but do we know D? Well, we've got two coordinates. Distance formula, so D equals the square root. We've got minus 9 minus minus 6, or the difference between minus 9 and minus 6, and the difference between 1 and 0. The difference between minus 9 and minus 6, minus 9 plus 6 is minus 3, that's squared of course. Square root of minus 3 squared plus 1 squared, that's 9 plus 1 is 10, root 10. So that equals root 10. R1 over to this side, you get 3 root 10 minus a root 10, so R1 equals 2 root 10. So now we've got a radius and we've got its centre, so the equation from the start exam paper is x minus a squared plus y minus b squared equals r squared. X minus minus 6 plus 6 squared plus y minus 0, so plus y squared equals, careful, 2 root 10 all squared. So working that out, I get x plus 6 squared plus y squared equals 2 2s is 4, root 10 times root 10 is 10, so that's 40, and we're done there.
SQA Higher Maths 2023, Paper 2, Question 11. Circle C1 has this equation and C2 has that equation. Find the distance between the centres for part A. So again, look at the start of our exam paper. It tells us that it's x minus a plus x minus b, y minus b squared equals 37. So the centre of C1 is just 4, opposite of minus 4, and minus 2, the opposite of 2. For the centre of C2, so if we examine C2 first of all, it is minus g minus f, where that is 2g and 2f. So we know that 2g equals 2 and 2f equals minus 6. So g is equal to 1 and f is equal to minus 3. So our centre of C2 is just minus g minus f minus 1, 3. So now we want the distance between them. So it's the distance formula already with Pythagoras. The difference between the x squared plus the difference between the y squared. So the distance is just going to equal the square root of, we've got 4 minus minus 1 squared plus minus 2 minus 3 squared. That is equal to 4 minus minus 1 is 5, so 5 squared. Minus 2 minus 3 is also 5, so 5 squared. Or minus 5 squared if you prefer. 25 plus 25 is root 50. We can simplify that as a third if we want, or just place root 50 in our calculator if you don't want to mess about with thirds. It is a calculator paper after all. But root 25, root 2, root 25 is 5, so we can leave it as 5 root 2, or put it in our calculator. Part B says, hence show that C1 and C2 intersect at 2 distinct points. So we already know that the distance between the centres is 5 root 2. Now, if you had put that in a calculator, you would get an answer of 7.07. So I'm just going to note that for now. And then for part B, to work out whether they intersect at 1 point, 2 points, or no points, you need to examine the distance between the radiuses. So I'm going to need my radiuses C1 and C2. So the radius of C1 is equal to the square root of 37 because it's equals r squared. The radius of C2 is given by the square root of g plus f minus c. G squared plus f squared minus c squared minus c. So the radius of C2 is equal to the square root of, remember our g and f were 1 and minus 3. So it's just 1 squared plus minus 3 squared. Take away c, which is the number on the end, minus 7. So it's minus 7. So that is 1 times 1 is 1, 3 3s are 9, minus 7 is plus 7. Plus 7, and 9 plus 1 is 10, plus 7 is root 17. So the distance between the centres is the radiuses is so the radius is C2 is just root 17. And we've got root 37 for C1. So we might as well turn them into numbers and add them together, because if you add up the radiuses and it's bigger than the distance between the centres, it means it touches at 2 distinct points. So illustrating that point, let's say we had 2 circles. You've got 2 options. We could touch like this, or we could touch like that, or I suppose we could be that. There's other options with it internal each other, but that's your main ones. If you look at the centres here, it's easy to see from the ones that don't touch, if that distance there, the distance between the centres, is bigger, that is obviously bigger than the radiuses, so we don't touch. That distance there is clearly the same as the radiuses added together, so we touch on the 1 point. That distance there then must be shorter than the radiuses added together. Or in other words, the radius added together is bigger than the distance between centres. We touch at 2 distinct points. So all we need to do is check what R1 plus R2 is. So R1 plus R2 equals root 37 plus root 17. So you get your calculator out, and that gives you 10.02. So since 10.02 is greater than 7.07, the distance between the centres, the circles touch at 2 distinct points. And we're done there.
SQA Higher Maths 2015, Paper 2, Question 5. Circle C1 has equation x squared plus y squared plus 6x plus 10y plus 9 equals 0. And the centre of C2 is 9, 11. There's C2 there, so let's just call that 9, 11. And the touch, determine the radius of C2. Well, we'll just find out all we can, so let's see if we can find the centre of C1. We have got this equation here, and we know from the start of the exam paper that minus g minus f is the circle's centre. So to get minus g minus f, you just divide these by 2 and change the sign. So that becomes 3, 5. So that's minus 3 minus 5. So we can write that for that centre. What else do we know? Well, we also know the radius of C1. So if we knew the radius of C1 and maybe this whole distance, we could find the radius of C2. So let's do the whole distance first. So the distance between, let's call it C1 and C2. Distance formula is Pythagoras, so it's 9 minus minus 3 squared, the x's, plus 11 minus minus 5 squared. That equals the square root of 12 squared plus 16 squared. That is 400, which gives me 20. So we now know the distance all the way up here is 20. So let's now find the radius of circle C1. So again, start of the exam paper, radius is equal to the square root of g squared plus f squared minus c. So we know g and f are just our centres. So therefore we can say the radius of C1 or R1 is equal to the square root of 3 squared is g plus 5 squared is f minus c, which is minus 9. So that is 9 plus 25 minus 9 is 25. So therefore the radius R1 is equal to 5 units. So we now know, I'll just use a different colour, that from here to here is 5. And therefore from there to there must be 15. Therefore R2 equals 20 minus 5, which is 15. And we're done there. So it now says, for part B, a third circle is C3 is drawn such that C1 and C2 touch internally with C3, and the centres of C1, C2, C3 are collinear, so they line up in a straight line. And we have to determine the equation of C3. A little sketch to illustrate this will be handy for you. This point here is minus 3 minus 5, and we know that the other point is 9, 11 here. And we want to know where the centre of the big circle is, and therefore what its radius is. So we're kind of looking at this line going through. Now we know the radius as well of C1 is 5, so we know that this line here is 10. We're going to go 5 on this side and 5 on that side. And we also know the radius of our big circle now is 15, or our big one in the middle. So that's 15 and 15. So we can use ratio to see how much the line divides the circles. So you should be able to see that a centre of the big circle, if I just kind of do it there, is kind of roughly there. So if I kind of mark that point, that's the centre of like C3 roughly there. And we need to know where that is. So let's see how we divide this up. So if I kind of just draw a right angle triangle here, there it is. you can see that this distance is going from -3 all the way over to 9. So that's 12. And we can see that this distance is from -5 all the way up to 11. So that's 16. So the diameter of a big circle is 30 plus 10, which is 40. So the radius of a big circle is 20. So we know that from the big circle from here to there is 20. Or just like that, the radius of 3 is 20 at the side. So we know that this bit here is like 5. So this bit in here must be 10 because it goes 10 plus another 10 makes 20. So that must be 10 in there. So if we think about moving from here to here, we move 15 units. And then from here to here, we move 5 units. So the ratio is 3 to 1. So if we divide 12 by 4, we get this line must be 3. And if we divide 16 by 4, this line up here must be 4. That must be a 3, 4, 5 triangle there. So then we can get the centre just by working backwards from 9, 11. It's taking 9, 11, our centre, which I'll just do in a different colour. 9 minus 3 is 6, and 11 minus 4, 7. So we get our centre of our circle finally is 6, 7. So we've got our centre and we've got our radius. So the equation is x minus 6 squared plus y minus 7 squared equals 20 squared. And we're done there. Or we can say x minus 6 squared plus y minus 7 squared equals 400. Okay, unusual circle questions, SQA Higher Maths 2019 paper 1 question 16 had this one. P is the point with coordinates 4k and C is the centre of the circle with this equation. Show the distance between P and C is given by square root of k squared plus 4k plus 13. So part A, we've got our points 4 and k and the centre of our circle is equal to, well, let's have a look. We've got 1 minus 2. So we can work out the distance between them. That is going to be the square root of the difference in the x's, 4 minus 1 squared, plus the difference in the y's, k minus 2 squared. Tidying that up, we get the square root of 3 squared plus k plus 2 squared. That equals the square root of 9 plus k squared plus 4k plus 4, which equals the square root of k squared plus 4k plus 13 as required. Part B says, hence otherwise find the range of values of k such that p lies outside the circle. So let's draw a little picture for this. We've got a circle and the centre of that circle is 1 minus 2. And we can look to see what the radius is. We know the radius is 5, the square root of 25. So that distance is 5, that's our radius. So if P is outside the circle, then clearly the distance between the centre and P must be bigger than 5. It has to be over 5. So we can then just say that the square root of k squared plus 4k plus 13 is greater than 5. And we can go from there. That's because our radius, remember, is 5. So, quadratic inequality, square both sides, k squared plus 4k plus 13 is greater than 25. Taking the 25 over, we get k squared plus 4k minus 12 is greater than 0. And this is a quadratic inequality, so we examine the roots. So looking at our roots, we've got k squared plus 4k minus 12 is equal to 0. Double brackets, we get k and k, 6 and 2, plus 6 minus 2 is 4. So our roots happen at k equal to 2, or k equals minus 6. Drawing a quick sketch then of that graph, we get 2's over here somewhere, minus 6 over here. It's a positive k squared, so it is a happy face. We don't need the turning point or anything because we're just looking to see when is this bigger than 0. Well, it's bigger than 0 above the x-axis, so it's over this side, it's always bigger than 0, and over this side, it's always bigger than 0 as well. So our final answer is k is less than minus 6, or k is bigger than 2. And we're done there.
SQA Higher Maths 2019, Paper 2, Question 2, integrate this polynomial. So we need to get it ready to integrate, just like with differentiation. So I'm going to change that to the integral of 6x to the half minus 4x to the minus 3 plus 5. And then we can integrate because we add 1 to the power and divide by the new power. So that gives me x to the 3 halves. Still times 6, but that's divided by 3 halves. We'll deal with that later. And then minus 4x to the minus 2. Minus 3 add 1 is minus 2. So divide by minus 2. Then plus 5x. And then remember to add your c. Okay, dividing by a fraction is the same as times by its reciprocal. So I can just do 6 times 2 is 12. So that's 12 over 3. X to the 3 halves. 4 divided by 2 is 2, minus divided by minus is a plus, so plus 2x to the minus 2, plus 5x, plus c. 12 divided by 3 is 4, so that's 4x to the 3 over 2, plus 2x to the minus 2, plus 5x, plus c. And you will get your final mark at that stage, but let's just assume you wanted to go further because you're going to use it in another question. This helps us revise indices. So we've got x to the 3 halves. So that's the same as x the square root because of the 2, x cubed, plus 2, x to the minus 2 over x squared, plus 5x plus c. But you don't need to go that far for this question.
SQA Higher Maths 2023 Paper 1 Question 6. Integrate 2x to the power 5 minus 6 root x dx for x greater than or equal to 0. So integration without limits means there's going to be a plus c. But I need to get it ready to integrate. Root x becomes x to the half. So I'm going to integrate 2x to the 5 minus 6x to the half dx. So integrate, add 1 to the power, divide by the new power. So x to the 5 becomes x to the 6, and I've got 2 sixths minus 6x, add 1 to a half, you get 3 halves. So I have to divide by 3 halves. And I've still got plus c. So dealing with the first one is easy. 2 sixths is a third. So we've got a third x to the 6. Divided by a fraction is the same as times and by its reciprocal. So times by it and then turn it upside down. So I've got minus 6 times 2 thirds x to the 3 halves plus c. So that gives me 1 third of x to the 6. 6 2s are 12. 12 divided by 3 is 4, so minus 4 x to the 3 halves plus c for our final answer. SQA Higher Maths 2024 Paper 2 Question 5. Evaluate the integral between 0 and pi over 7 of sine 5x dx. A simple one this. Start of exam paper tells you if you integrate sine ax you get minus 1 over a cos ax. So that's what I'm going to get. Minus 1 over 5 because that's my a cos 5x. Plus, well, not plus c because I'm putting numbers in. And that's the chain rule. What has happened here is you've the derivative of 5x, which is 5, and divided by it, and sine goes to minus cos. So now I just sub my numbers in as per usual. Minus 1/5 cos 5 pi over 7. That's one of them. Take away minus 1/5 cos 5 times nothing. I'll just put nothing in. Now, not expected to know these. Calculator job. Make sure I'm in radians. So let's just check it's minus 1/5 at the front. Right. So minus 1/5, 1 divided by 5 is 0.2. So I'm just going to do that. Minus 0.2 times cos bracket 5 pi over 7 is 0.1247. Say. And minus, well, cos is 0 you should know is 1, but I mean, we've got a calculator here, so let's just check 1. So minus 1/5 times 1 is minus 1/5, so we've got a minus 1/5. Well, 1/5 is 0.2, I've already established that. So it's 0.1247 plus 1/5, which is 0.3247. Or, if you wanted to round it, 0.325, I suppose, would be fine. And there's no degree sign or nothing like that. We're in radians anyway. So we're done there.
SQA Higher Maths 2023 Paper 2 Question 3. integrate 7 cos 4x plus pi over 3 dx. So we're going to use the chain rule here because we've got an inner function. So integrate cos, well, cos goes to sine, using the start of exam paper. So that integral straight away becomes 7 sine 4x plus pi over 3. But then we need to divide by the inner function differentiated. So differentiate 4x, you get 4. Pi over 3 is nothing, so it's just 4. And then we've got plus c, remember, don't forget your plus c. We could leave it like that, but I'm just going to tidy that up slightly by taking the fraction outside. So we get 4x plus pi over 3 plus c, and we're done there.
SQA Higher Maths 2022, Paper 1, Question 6. Integrate between minus 5 and 2, 10 minus 3x to the power of minus a half dx. Okay, let's start working on this. So we've got the integral of minus 5 and 2 of 10 minus 3x to the power of minus a half dx. Well, we can start to integrate this by adding 1 to the power. So we've got 10 minus 3x to the power of a half. We then need to divide by the bit inside the brackets differentiated. So inside the brackets is 10 minus 3x. If we differentiate that, you get minus 3. So we need to divide by minus 3, or in other words, that's the same as times it by minus a third. You get your first mark for just starting to do that, and you get your second mark for showing anywhere that you are going to be dividing by minus 3 or timesing by minus a third. So there's your first 2 marks there. And then we need to process our limits. So let's tidy this up a little bit before we get to that. So we get 10 minus 3x to the power of a half. Dividing by a half is the same as timesing by 2. We've got a minus because of the timesing by minus a third, divided by 3. Now, our limits are 2 and minus 5. So we've got minus 2, 10 times minus 3 to the times 2 to the power of a half divided by 3. There's our first limit, and that is minus 2, 10 minus 3 times minus 5 to the power of a half divided by 3. So there's our 2 limits because it's between minus 5 and 2. So your third mark is actually coming in at this point. For substituting in 2 and minus 5 and putting the minus in between, you are getting that mark. So there's your third mark there. And then your final mark is for actually working that out. So let's work that out now. Just being very careful. So we've got minus 2. 10 minus 6 is 4. So it's times the square root of 4, because the power of a half is square rooting, divided by 3, and that's minus. And then we've got minus 2 again. 10 minus 3 times minus 5. Well, that's minus 3 times minus 5 is 15. So that's 10 add 15, which is 25. So it's times the square root of 25 over 3. Working out that, we get minus 2 times 2, which is minus 4 thirds, minus 2 times 5, which is minus 10 thirds. Minus 4 plus 10 is 6, so that's 6 thirds, which is equal to 2 in the end. So if you can get down to getting 2, there's your final mark there for working that out. Okay, let's go through some key points of where you could go wrong in this question. If you differentiated and didn't integrate, unfortunately, you get no marks at all, even if you're substituting numbers in. There's no way to get any marks for that. If you start to integrate individual terms, if we go back to the standard, the actual question, if you're trying to integrate, say, the 10 to get like 10x, and then the minus 3x to get something like minus 3 over 2x, you're just doing it inside the bracket, or you're trying to expand the bracket, you can't get any more marks after that as well, because it's just invalid, it doesn't work. For mark 4 down here, it's only available for non-integer power. So in other words, if your power here I've got a half as the correct answer. If you'd used squared or cubed or 4, that we wouldn't get a mark because we're checking if you can do the third part as well. Okay, integrating a trig function again with a chain rule. We've got Higher Maths 2019 paper 1 question 11. Evaluate the integral between 0 and pi over 9 of cos 3x minus pi over 6 dx. Exact value question as well because it's non-calculator. So let's start integrating. That becomes cos goes to sine, remember? We're looking at the start of the exam paper. The whole function 3x minus pi over 6. But then we need to differentiate this. Well, that's just a number, so that's nothing. That becomes 3. So divide by 3. And that is the integral between 0 and pi over 9. So there's our first step. Now we need to just substitute in. So that gives us a third of sine, well, 3 times pi over 9, we'll just write, minus pi over 6. That's our first one. Take away our second one, subbing 0 in. So that's a third. Sine 3 times 0 minus pi over 6. Okay, so we can now, we'll just tidy that up, put an extra bracket on. We can now just evaluate that. So that gives me 1/3. If I take my first one, sine 3 pi over 9. So let's just do this. 3 pi over 9 is pi over 3. So I've got pi over 3. And then our pi over 6, we can think of that as minus pi over 6. Take away a third of sine. And then 3 nothings is nothing, so it's just minus pi over 6. So that gives me 1/3 of the sine of, well, pi over 3 is 2 pi over 6, minus pi over 6 is pi over 6. So we've just got pi over 6 now. Take away a third of the sine of minus pi over 6. So we're going to have to work out what the sine of pi over 6 is. So if you're thinking in degrees, pi over 6 is the same as 180 over 6, which is 30 degrees. So exact value triangles is how I always think of this. So if I got myself a triangle with 2 on this side, 1 on that side, then by Pythagoras, 2 2s is 4, minus 1 is 3, that is root 3. Now that was 60, so that one's 30. The sine of 30 degrees is equal to a half. You might have just memorized that yourself. If you think of a sine graph or a cast diagram, you can see that minus 30 would be about here. It's obviously minus a half for the sine of minus 30 degrees. 1/3 of the sine of 30, so 1/3 times a half, minus 1/3 times minus a half. So a third times a half is a sixth. A third times minus a half is minus a sixth. So plus another sixth because of minus times a minus. That is 2 sixths. That is 1/3. And we're done there. Getting with chain rule. SQA Higher Maths 2018 paper 1 question 14. Find the integral between 9 and minus 4 of this function. Going to have to get it ready to differentiate first. So we've got between minus 4 and 9. 1 over. So it's the cube root, so that's to the power of a third, but it's squared, so it's to the power of 2/3. So it's 2x plus 9 to the power of 2/3 dx, which equals the integral between minus 4 and 9, taking it up to the top, 2x plus 9 to the minus 2/3 dx. And now we can integrate it. So we add 1 to the power and divide by the new power. So being very careful, we've got 2x plus 9. Add 1 is a third. Divide by our new power. So divide by a third, but also divide by this differentiated, which is 2. So I can say times 2 on the top bottom as well, and that is between -4 and 9, which I'll substitute in when I'm ready. Now this is a non-calculator question, so I'm going to have to put it back into root form as well. So that gives me 2x plus 9 cube root. So I can just write the cube root of 2x plus 9. 2 times a third is 2/3. And that's between -4 and 9. Almost done. Dividing by a fraction means we can times it by the reciprocal, flip it upside down in other words. So we get 3 times the cube root of 2x plus 9 over 2 between -4 and 9. And now I'm ready to substitute my numbers in. So substitute 9 in, take away, substitute -4 in. So subbing in my numbers, get 3 times the cube root of 2 times 9 plus 9 all over 2. I'll just put that in big brackets. Minus 3 times the cube root of 2 times -4 plus 9. I'll just make that clear that that's separate all over 2. And now we can work some of that out. So that's 3 times the cube root of 2 9s is 18, 18 and 9 is 27 over 2, minus 3 times the cube root of 2 times -4 is -8, add 9 is 1 all over 2, and that's handy because that now simplifies quite easily. The cube root of 27, 3 times 3 is 9 times 3 is 27, so this just gives me 3 times 3 over 2 minus cube root of 1 is 1, 3 times 1 over 2, that equals 9 over 2 minus 3 over 2, which equals 6 over 2, which equals 3. And we're done there. Equations SQA Higher Maths 2019, Paper 2, Question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. The graph of y equals f of x crosses the x-axis 7, 0. Express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment. But it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed, minus 16 over 2 is 8x squared, plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed, minus 8 times 7 squared, plus 11 times 7, plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there.
SQA Higher Maths 2023, Paper 2, Question 12. A curve for which the y by the x equals 8x cubed plus 3 passes through minus 1, 3. Find y in terms of x, or differential equation. And integrate the y by dx to get y, but that's going to have plus c, so sum in the point. So y equals the integral of 8x cubed plus 3 dx. So y equals, add 1 to the power, divide by the new power, so 8 over 4 plus 3x plus c, or y equals 2x to the 4 plus 3x plus c at the point when x equals minus 1, y equals 3. So subbing that in, we'll get 3 equals 2 times minus 1 to the 4 plus 3 times minus 1 plus c. So 3 equals 2 minus 1 to the 4 is 1. 3 times minus 1 is minus 3 plus c. 3 is minus 1 plus c, so c equals 4. And therefore, we just rewrite our equation with the c replaced by the number 4. 2x to the 4 plus 3x plus 4. And we're done there.
Differential equations, SQA Higher Maths 2015, Paper 1, Question 15. The rate of change of a mug of coffee is given by this differential equation. It tells you some information. Express t in terms of t. What you need to realise is if you integrate a dt by dt, you just get t back. So we can just immediately say that t equals the integral of the right-hand side, 1 over 25 t minus k. And that will be with respect to t, because it's dt instead of dx as normal. So we'll just integrate and let's go. So we get 1 over 25 t squared, and then we times by a half because we divide by 2, and then minus k times t, but then we've also got plus c. So there is our integral. Let's just tidy that up. Dividing by a half, we get 1 over 50 t squared minus kt plus c. So there's our initial step, but then we need to eliminate that c, but luckily we're given some information. It says initially the temperature of the coffee is 100 degrees. 10 minutes later, the temperature has fallen to 82 degrees. Express t in terms of t. So, first step, we know that initially, when t is 0, the temperature is 100. So we can say that when t equals 0, big T equals 100. Subbing all that in, we get 100 equals 0 minus 0 plus c. In other words, c equals 100. So we've now got t equals 1/50th of t squared minus kt plus 100. But we need to find this k, so we've got an extra bit of information. 10 minutes later, the temperature is 82. So in other words, when t equals 10, big T equals 82. Subbing that point in, we get 82 equals 1/50th of 10 squared minus k times 10 plus 100. So we just need to solve and get k back out. 82 equals 100 over 50 minus 10k plus 100. Just quickly running through this, you get 2 minus 10k plus 100. So you get 82 is 102 minus 10k. Moving the 10k over to this side to make it positive. That is 102 minus 82 is 20. So k is 20 over 10, which is 2. So our final answer is just t is equal to 1/50th of t squared minus 2t, because k is 2, then plus 100. And we're done there.
SQA Higher Maths 2024, Paper 2, Question 7. The diagram shows the curve of equation y equals x cubed minus 6x squared plus 11x, intersecting the curve of equation y equals 6 plus 4x minus 2x squared at x equals 2, which is here. Now, I've took a liberty shading this in before I filmed this because there was no way that with a scan you could tell what bit you were actually meant to be finding. So it is that purple bit that I've shaded in for you. So we've got two curves. We've got an upper and a lower. So let's identify the curves. This one is above and this one is below, so it's upper minus lower. So it's the integral between 0 and 2, because that's an area. The upper curve is 6 plus 4x minus 2x squared, and we have to take away x cubed minus 6x squared plus 11x dx. So we need to work some of that out. Integral between 0 and 2 then. I've got 6, 4x minus 11x. So 4 minus 11, 4, 5, 6, 7, 8, 9, 10, 11, 6, 7, minus 7x. I've got minus 2x squared minus minus, so that's plus 6x squared. 6x squared minus 2x squared is 4x squared. And then I've got minus x cubed. Now you can rewrite that in a different order if you want, but I don't see the point, so just leave it like that. Now we just integrate 6x minus 7x squared over 2 plus 4x cubed over 3 minus x to the 4 over 4, and we sub in 0 and 2. Okay, so always write your substitution because you get marks at this point. So there's my first bit subbed in with a 2, and then take away 0. Now it is all 0, but I'll write it anyway for the sake of the video. But you should be able to see that we're all x's and zeros, so it's just all that 0. So now be very careful doing it in stages if you have to. So I'm just going to do 6 times 2 is 12. 2 2s is 4, divided by 2 is 2. 2 7s is 14. Now use a calculator anytime you want, but I usually do each term individually. 2 cubed is 8, 8 4s is 32. So that's 32 over 3, which I'll just leave as a fraction for now. 2 2s is 4 times 2 is 8 times 2 is 16. And 16 divided by 4 is 4. So that's my bracket. Take away 0, 0, 0, 0, 0. So we have got 12 minus 14. 12 minus 14 is minus 2. Minus 2 minus 4 is minus 6. So we've got minus 6 plus 32 over 3. And because I can't actually bother get my calculator out, I'll just work that out for you. 6 3s is 18. So that's minus 18 over 3 plus 32 over 3. Now 32 minus 18 is 22, 12, 14. So you get 14 over 3. That is an actual simplified fraction. It's an area, so it's got units and it's squared, and we're done there. Question 4 says the graph has an equation x cubed minus 5x squared plus 2x plus 8. The total shaded area bounded by the curve and the x-axis. We've got this area here and this area here. In the first part of the question, calculate the shaded area above the x-axis, so between minus 1 and 2. So for part A, we need to integrate between minus 1 and 2 our function x cubed minus 5x squared plus 2x plus 8 dx. And that'll give us the area. So x cubed becomes x to the power of 4 over 4 minus 5x cubed over 3 plus 2x becomes x squared divided by 2, still x squared, plus 8x, and we're doing that between the limits of minus 1 and 2. So we need to substitute 2 in, take away, then substitute minus 1 in. So for our first bracket, we've got 2 to the power of 4 over 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. Take away our second bracket, minus 1 to the power of 4 over 4 minus 5 minus 1 cubed over 3 plus minus 1 squared plus 8 times minus 1. So let's work out each bracket separately, and I'm going to keep it as fractions so that our answers as nice as possible. I'm just using my calculator to get those fractions. So our first one, we have got 4, so the first term, minus 13 thirds, plus 4, plus 16, and we're taking away a quarter, plus 5 thirds, because it's minus times a minus, plus 1, take away 8.
So for the first bracket, we would get 10 and 2/3 minus the second bracket, which is minus 5 and a 12. So adding them together, you would get 15 and 3/4 units squared as our area.
Part B then says, hence calculate the total shaded area. So we've already got this bit, so we just now need to work out the integral between 2 and 4. And just a reminder, when you're wanting to work out an area when it's below as well, you would do this one, take away this one, and that will give you your total area. So for part B, we've got our integral already between minus 1 and 2 of x cubed minus 5x squared plus 2x plus 8. And we're going to take away the integral between 2 and 4 of the same thing, x cubed minus 5x squared plus 2x plus 8 dx. Put that bit in brackets just to separate it out, and I'm going to do that bit first. I already know the answer to this bit. Let's just write that down. So that gives us 15 and 3/4 minus, let's just start integrating now. So we already know the answer to that, so there's no extra work required. It's a quarter x to the 4 minus 5 over 3x cubed plus x squared plus 8x, and that's between 2 and 4. So keeping that 15 and 3/4 just floating about, minus, let's just use big brackets. Let's substitute our 4 in to start with. So we end up with 4 to the power of 4 over 4 minus 5 times 4 cubed over 3 plus 4 squared plus 8 times 4. So that's our first limit. Take away our second limit, which in this case is 2, so it's a quarter. 2 to the power of 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. 15 and 3/4 minus the first bracket, it's 64 minus 106 and 2/3 plus 16 plus 32. That's this bracket here. And this bracket we already know the answer to because we did it in part A, so we might as well just write down the answer. That was 10 and 2/3. So take away 10 and 2/3. $15 and 3/4 minus first part of the bracket gives you 5 1/3 minus 10 and 2/3. So that means our area is 15 and 3/4 minus the answer to this, minus 5 1/3. Minus minus, so it's adding them together. So 15 and 3/4 plus 5 1/3 gives us a final answer of 21 and 1/12 units squared.
Mr. Clelland here from Clelland Maths. Today we're going to be looking at a paper 2015 paper 2 question 4 of the SQA Higher Maths Exam paper. Let's jump straight in. Okay, this one was about a wall plaque made to commemorate the 150th anniversary of the publication of Alice in Wonderland. Okay, so the edges of a wall plaque are modelled by quadratic functions, and there's 1, 2, 3, 4, and it gives you 4 bullet point equations. So what makes this one difficult is it will give you all these equations, all this information, but you just need to keep your head. So let's look at part A. Find the coordinate of the point of intersection of the graphs of y equals f of x and y equals g of x. So point of intersection means simultaneous equations. So the two ones I need are this one and this one. Since that would equal y and y, so I can just make both of these equal to each other. So to get 1 mark for part A, I'll just do here. I can just write a quarter x squared minus a half x plus 3 equals a quarter x squared minus 3 over 2x plus 5. And that will give you your first mark. Okay, now we need to solve that to get the x part. And it only asks for the x part, so that's good. Notice if you've got the same thing on both sides, they just automatically cancel. So immediately I can just get like a red pen or something and go, that's the same as that. Same sign and everything, so I can cancel them. I've got minus a half x, so I can add 3 halves x to both sides. And that will get rid of it on this side. So let's just do that and do it in stages. 3 halves take away 1 half is 2 halves, which is 1. So that just gives us x left on this side plus 3 equals 5. And then we can just solve that to find x. Take away 3, so x equals 2 is unlikely as it seems our answer. Part B says the graphs of f of x and h of x intersect on the y-axis. The plaque has a vertical line of symmetry. Calculate the area of the wall pack. You should know a power word for integration is area. So if it says area, you need to integrate and you need to find the two limits. So we've already got our first limit, it's 0. We need to know this one. Well, this one is going to be the same as this one, which you worked out in part A, where these two intersect, was 2. So that's just 2. So I need to do the integral of the upper f of x minus the lower h of x between 0 and 2. So making sure you copy it down properly, it's the integral between 0 and 2 of f of x, which is a quarter x squared minus a half x plus 3. Put that in brackets. Take away h of x, which is this one, 3/8 of x squared minus 9/4 of x plus 3 dx. So at that point, you may be wondering, well, how much marks do I get? Well, at that point, you get a mark for knowing to integrate, so using the integration sign, just that. Another mark for putting in the limits 0 to 2, and then another mark for writing down the two curves taken away from each other. So 3 marks for literally doing no work. It's not bad, that. And then we need to integrate it, and you actually only get 1 further mark for the integration. So all the tidying up you're going to do now, you're not going to get any marks for, but you still need to do it to be able to integrate. So let's tidy this up. So that gives us the integral between 0 and 2. You've got a quarter x squared minus 3/8 x. So a quarter is 2/8. So being very careful, you've got 2/8 minus 3/8. You've got minus an eighth of x squared. Looking at the x parts, you've got minus a half minus minus becomes plus. So plus 9/4. Well, putting a half into quarters is 2/4. So you've got minus 2/4 plus 9/4 is 7/4. So plus 7/4 x. And then we've got our number parts, but they cancel. 3 take away 3 is nothing. So we get the integral of this between 0 and 2. And then we need to integrate it. So that gives us x cubed. Add 1 to the power and divide by the new power. So 3 times 8 I need to do, which is 24. And then plus x squared. I've got 7 still, but I need to divide by 2. So I've got 4 already on the bottom, so 4 times 2 is 8. And that's between 0 and 2. So that gives us another mark at that point. So let's move on and substitute our limits in. So we've got minus 2 cubed over 24 plus 7 times 2 squared over 8. Take away minus 0 cubed over 24 plus 7 times 0 squared over 8. Okay, so we get a mark for our substitution. And then we need to evaluate it to get another mark. So we could use a calculator at this point because it is a calculator paper, but I'll just go ahead and do it without. So we've got 2 2s are 4 times 2 is 8 over 24, so minus 8 over 24. And then the other number, 2 2s are 4, 4 7s is 28, so you get 28 over 8. And luckily, you've substituted 0 in here, so that is a big fat 0 for this. 0 cubed is 0, over that is still 0, 0 squared is 0, over that is still 0. So you just need to work out these fractions. So I can simplify the fractions. Well, actually, I'll add them first before I simplify because it'll be easier to see. So minus 8 over 24. And then we've got 28 over 8. 8 threes is 24. So times them by 3. I get 3 times 20. So we get 84. So now we can add them. 84 take away 8 is 76 over 24. Simplify that because you have to always have simplified answers. So I'll just divide through by 2 to get 35, 36, 37, 38 over 12. Divide them by 2 again to get 19 over 6. And 19 is a prime number. 6 doesn't go into it. So 19 over 6 is our final answer for another mark. And feel free to do that in any way you want to get 19 over 6. But that isn't the answer. You need to check your question. Calculate the area of a wall plaque. Well, we have calculated the area from here to here. So all that bit, if I was to draw a line down here, but you can see it's symmetrical. It even tells you it's symmetrical. So the area of the wall plaque is double the area I just found out. So our final area, just to get our final 7th mark, the area, our like total, equals 19 over 6 times 2. 2 times 19 over 6, well, that's the same as 19 over 3. So 19 over 3 is our final answer for our final last mark. This has been Clelland Maths today. We've been looking at an integration question, quite a difficult one from 2015, paper 2. Take care, stay safe, and goodbye.
The chain rule. SQA Higher Maths 2016, paper 2, question 10. Given it y equals x squared plus 7.5, find the y by the x. And then part B, hence find the integral of this function, which we'll use our answer to part A to do. So part A, the y by the x is equal to, take the half down to the front, x squared plus 7, take 1 off the power, minus a half, and then we differentiate the bit inside the brackets, which is x squared, so that becomes 2x. So that equals 2x divided by 2 is just x, so x bracket x squared plus 7 to the minus a half. And then try to make it look a bit like our part B, that's x over x squared plus 7 to the half, which is equal to x over the square root of x squared plus 7. Part B says integrate 4x over square root of x squared plus 7, which is very similar. So if I do part B, integrate 4x over the square root of x squared plus 7 dx, well, if I just take that 4 out, I get the integral of x over the square root of x squared plus 7 dx, which I already know is exactly the same as what I found out up here, my differential. This integrated is exactly that. So I can just write the integral as x squared plus 7.5. Simple as that. So that means I've got my answer is 4 times x squared plus 7 to the power of a half. Or, let's make that neater, x squared plus 7 to the half. I've forgot my plus c, so there we are, plus c, and we're done there.
18, paper 1, question 9 on vector pathways. It shows us a triangular prism and it tells us some of the vectors. It says A to B is T, A to C is U, and A to D is V. Express B to C in terms of U and T. So I want to get from B to C, so I can go down this route minus T and then along here plus U. Job done. B to C equals minus T plus U. And we're done there. Let's do part B. M is the midpoint of B to C. Express M to D in terms of T, U, and V. So we're wanting to go from M, which is here, all the way over to D, and we need to see a pathway we can take. So we could go down here, along there, and up here. So I suppose we need to work out what M to C is. So let's do that. M to C is equal to a half of B to C, which is equal to a half of minus T plus U. So now we know that, then M to D is simply looking at our root, a half of
minus t plus u. And then, once we've done that, we go minus u plus v. Minus u plus v. Simplifying that, that's all minus a half t plus a half u minus u plus v. That's minus a half t, a half u minus u is minus a half u, and then we've got plus v. Done there. Just put little lines underneath, because usually that's how you write vectors or both. SQA Higher Maths 2018, paper 1, question 12 on vectors, addition and the modulus. Vectors A and B are such that A is this and B is that. Express 2A plus B in component form. So component form is when you've got the brackets. So we've got 2A plus B, well that equals 2 times A, 2 4s are 8, 2 2s are 4, and 2 2s are 4 as well, plus the B, which is minus 2, 1J, and PK. So then we can just add each element. 8 minus 2 is 6, minus 4 plus 1 is minus 3, and we've got 4 plus P on the end. And we're done there. Part B. B says, hence find the values of P such that the modulus of 2A plus B is equal to 7. Okay. Modulus is the size of, right? So we've got the size of 2A plus B. Well, that equals, it's just Pythagoras, square each numbers and square root. So that's the square root of 6 squared plus minus 3 squared plus 4 plus P squared, and that equals 7. Now, that's a little bit unwieldy what to do. We'll sort of square both sides to get rid of the square root. So that gives us 6 squared plus minus 3 squared plus 4 plus P squared equals 49. Expand the brackets and simplify. 36 plus 9. 4 4s are 16. 4 times P is P, times 2 is 8P. P times P is P squared. That equals 49. Moving everything to the same side and making it look like a quadratic then, because it's got a P squared, we get P squared. And then we've got 36 plus 9 is 45. Plus 16 is 55, 61. So plus 61 on the end. And then we've got plus 8p in the middle. And that equals 49. So moving the 49 over to make it a quadratic we can solve. 61 minus 49 is 12. That equals 0. So hopefully that's factorizable. From National 5 Maths, 2 numbers at times to make 12, but add to make 8. That must be 6 and 2, plus and plus. And therefore, P equals minus 2, or P equals minus 6. And we're done there. SQA Higher Maths 2016, paper 1, question 7 on vectors. 3 vectors are expressed as follows. I'm not going to read them out, but it then says find F to H and then find F to E. So we can get a handle of what this question is asking us. If I draw a little picture, let's just call this F. I'm going up to G first. So there's G. And then it goes G to H. So let's just call that H. And then it goes H, E to H. Well, I could go H to E then and just go the other way around for E to H. And then we could kind of complete the picture, I suppose, by saying that there's going to be a vector there. That's going to be my F to E. I have to find that one. So that's part B, say. And I have to find F to H, which is along the middle. So that's my part A. So we know, remember, all the solid lines. So for part A, F to H is equal to, let's just trace this out to make sure we don't make any mistakes. What I get from F to H, so I just go F to G plus G to H. F to G plus G to H. Now I find writing the vectors in this form easier, so F to G is minus 2, minus 6, 3. Plus G to H is 3, 9, minus 7. Adding them together, minus 2 plus 3 is 1. Minus 6 plus 9 is 3. And then 3 take away 7 is minus 4. So we get 1, 3, minus 4. Just writing that in the same format as the question. That's I plus 3j minus 4k. And we're done there. Part B, find f to e. So we want to get from here to here. We can't go that way. So we can go any way we want, remember. So we can just go that to that and then that. But we might as well just go straight across now, because we know that, and then go down. So it's f to h plus h to e. F to h plus h to e. Well, we know f to h, we just did it. 1, 3 minus 4. Plus h to e, well, it tells us e to h. So h to e is just the minus of that. So it's minus 2, minus 3, minus 1. Minus 2, minus 3, minus 1. 1 minus 2 is minus 1. 3 plus minus 3 is 0. And minus 4 plus minus 1 is minus 5. Or writing that out, minus I minus 5j. And we're done there.
SQA Higher Maths 2019, Paper 1, Question 5 on vectors and collinearity. So it says show that the points A, B and C are collinear and then state the ratio that B divides A to C. So let's do part A first. To show that 3 points are collinear, especially 3D points, we can just compare A to B and the vector B to C. So let's do A to B first. Vectors A to B, remember, is B minus A. So vector B is 4 minus 1 and 0. Minus A, which is 1, 5, minus 3. So we've got 4 minus 1 on the top is 3. Minus 1 minus 5 is minus 6. And 0 minus minus 3 is 3. So we get 3 minus 6 and 3 for the first. The next one, B to C. That's C minus B. So that is 8 minus 9 and 4. Take away 4 minus 1 and 0. So 8 minus 4 is 4. Minus 9 minus minus 1. Well, that's plus 1, so that's minus 8. And then the last one, 4 minus 0 is 4. Now, to show that they are collinear, we need to show that these two vectors are parallel. How do we do that? Well, all you have to do is show that you can times 1 to get the other. So if we just compare each element in turn, we do that divided by that divided by that, and that divided by that, and make sure we get the same answer. So 4 divided by 3 is the first one. And then we've got minus 8 over minus 6. Well, if I simplify that, divide that by 2, you get 4 over 3. So that's the second element. And then the third element, 4 over 3 again. So we can then say quite easily that B to C is equal to 4/3 of A to C. A to B, sorry. And therefore, BC and AB are parallel. You could have also done the numbers the other way around and said 3/4 and said that A to B is 3/4 of B to C, and it would make no difference. But we've shown the parallel, and but B is a common point, which you can see because you've got BC and AB. So you just say B is a common point, and therefore AB and C are collinear. And we're done there. SQA Higher Maths 2024, Paper 1, Question 4. P and Q have these coordinates, and R divides PQ in the ratio 2 to 3. Find the coordinates of R. So we've got a picture, I suppose, like this, and we've got a P down here and a Q up there. We've got R somewhere there, and the ratio is 2 to 3. So a quick and easy way to remember this is that 2 times that equals 3 times that. It's as simple as that. So we can just write 2 of RQ equals 3 PR. Now, where does that come from? Well, it really comes from the fact that PR over RQ is 2/3. So you get there quite quick, and then you can expand and simplify. Now, there is some tricks that some teachers teach where you do something about adding the coordinates and dividing. So you can say that at this stage, if you remember that trick, it's 2Q plus 3P all over 5. That is a quick way, but I never do the quick way. Do maths properly. So we've got 2Q minus R equals 3R minus P. So that's 2Q minus 2R equals 3R minus 3P. And I want R, so I'll take R's over to this side to get 5R. And then the Q and the P is going to be over here. And that's your 2 and 3. So you've got 2q plus 3p all over 5 equals r. Like again, you could have seen that from this kind of pattern, 2q, 3p over 5. So then we just put in what our numbers were. So q was minus 1, 11 and minus 8. So that's 2 minus 1, 11 minus 8 plus 3 minus 6, 1, 2 all over 5. So that gives me minus 2, 22 and minus 16 plus 3 6s is 18, 3 1s is 3 and 3 2s is 6 all over 5. Finally, that gives me minus 18 minus 2 is minus 20, 22 plus 3 is 25, minus 16 plus 6 is minus 10. All that divided by 5 is final answer of minus 4, 5 and minus 2. And we're done there. So we can then say that that's r. So our coordinate r to answer the question is minus 4, 5 and minus 2. And we're done there. SQA Higher Maths 2019 Paper 2 question 3 on vectors and vector pathways. It says EABCD is a rectangular based pyramid. It tells you that A to B is P as shown, A to D is Q as shown there, and A to E is R. And we have to express B to E in terms of P and R. So where's B to E? I need to start here and get up to there. So maybe you can take any direction you want. So I can just trace this. I go minus P. So I can write minus P. I've done minus P and I want to get all the way up to E. So I can go up R. So plus R. And that's it. It really is as simple as that. Point F divides BC in the ratio 3 to 1. Express the vector EF in terms of P, Q and R. So EF, just to be clear, is from here down to there. I want to get to there, but I need to go a path that I can actually use. So we could go along there, down there, and then back to there, and that will give me that. So let's just trace that out. I've got minus R plus P. So let's write that down to start with, minus R plus P. And then once I've done minus R plus P, I need to go along here. How far along am I going? Well, it says it divides it in the ratio 3 to 1. So if I imagine that this whole length is 4, I've went along 3 out of 4 bits. 3/4. And what is B to C's vector? Well, it's the same as this one because it's parallel. So it's 3/4 of Q. So plus 3/4 of Q. And we're done there. 2019 Paper 1 Question 9 on vectors and scalar product. Vectors U and V have these components where P is a member of the real numbers. Find an expression for U dot V for part 1. Well, U dot V is told to you at the start of the exam paper. If you forget, it's either got an angle in it or it is times each element, then plus the second element, then plus the third element, all times together. So I can just write that down. I've got P times 2P plus 16 plus minus 2 times minus 3 plus 4 times 6. So then we can just simplify that, expand my bracket, I get 2p squared plus 16p plus 2 3s are 6, minus times a minus is a plus, 6 4s is 24. So that's 2p squared plus 16p plus 30 is our simplified U dot V. Part 2. Determine the values for P for which U and V are perpendicular. Well, if U and V are perpendicular, that means that U dot V equals 0. And why is that? Well, if you look at the start of the exam paper, you're given the formula sheet, which says that U dot V is also the size of A times the size of B times the cosine of theta. Now, if theta was 90, cosine 90 is equal to 0, so U dot V is 0 when they're perpendicular. But you could just memorize that. So U dot V equals 0 means I can write 2p squared plus 16p plus 30 equals 0. Take 2 out as a common factor, p squared plus 8p plus 15. So that's a quadratic. So from National 5 Maths, I'm looking for double brackets probably. Two numbers that times together to make 15, but add together to make 8. Well, that's 5 and 3. So it's plus 5 and plus 3. So that means that p plus 3 equals 0 or p plus 5 equals 0. Solving both of the equations, we get p equals minus 3 or p equals minus 5. And we're done there. Part B says, determine the value of p for which U and V are parallel. So for parallel, that means that I can times this one by something to get this one. So let's just compare the elements. I've got minus 3 over minus 2, that's 3/2. And similarly, I've got 6 over 4, which is also 3/2. That means that if I times this one by 3/2, I get this one. So I can just write that down. 3/2 of p equals 2p plus 16. So for part B, 3/2 of p equals 2p plus 16. So I've got that equation to solve. So if I put brackets around that side, that means I can times by the bottom. So 3p is equal to 2 times 2p plus 16. 3p equals 4p plus 32. So taking it over to the other side, you would get minus p equals 32, or p equals minus 32. And we're done there. SQA Higher Maths 2024 Paper 2 Question 3. The coordinates d, e and f are given by these 3D coordinates. Express e to d and e to f in component form, and then calculate e to d dot e to f and find the angle. Oh, that's nice. We're doing it in bits, are we? So let's do e to d. So remember, that's just d minus e. So d is 2 minus 3 and 4. And e is 1, 1 minus 2. Taking them away and being careful not to mess it up. 2 minus 1 is 1. Minus 3 minus 1 is minus 4. And 4 minus minus 2 is 6. So there is e to d. Same for e to f. F minus e, that is. So we've got 3, 2, 1. Minus 1, 1 minus 2. 3 minus 1, that's 2. 2 minus 1 is 1. 1 minus minus 2 is 3. So that's us done part A. Part B, part 1, ed dot ef. So we have to do ed dot ef. So ed is 1 minus 4, 6. I have to dot that with 2, 1 and 3. So that's 1 times 2 plus minus 4 times 1. Don't know why I'm writing a plus sign here. Plus 6 times 3. 1 times 2 is 2. Minus 4 times 1 is minus 4. 6 3s is 18. 2 minus 4 is minus 2. Minus 2 add 18 is 16. So we get 16. Hence, otherwise calculate the size of angle DEF. Well, let's just check it. We're not trying to trick us here. We've got E to D, E to F, say. So, yep, I think that's okay. So we're just doing the angle in between. So from the start of the exam paper, if you just look, you get A dot B equals size of A, size of B, cos theta. So just slightly rearranging that, cos theta is A dot B over size A, size B. So for this example, cos theta is, we've got ED dot EF, ED dot EF, all over the size of ED and the size of EF. So that is just 16 over something. So I need the size of ED. So let's look at ED again. ED is equal to 1 minus 4 and 6. So the size of that is just Pythagoras, square root 1 squared plus minus 4 squared plus 6 squared. That is 6 6s are 36, 4 4s is 16, 36 and 16 is 46, 52, plus 1 is 53. So you get root 53 for that one. And then EF, remember, we had 213. So the size of EF is just equal to the square root of 2 squared plus 1 squared plus 3 squared. 2 2s is 4, 3 3s is 9, 4 and 9 is 13, and 1 is 14, I think. So we get root 14. So that means that our cos theta is equal to 16 over root 53 root 14. So now it's a calculator job to get theta. Theta is the inverse cos of all of that nonsense. 16 over root 53 root 14. Shift cos 16 divided by, open bracket, root 53 times root 14. I get 54.028. Or if you want to round it, degree sign anyway, 54 degrees would be perfectly acceptable, I think there. 52.03, 52. Who cares almost? And there we are, we're done there.
SQA Higher Maths 18, paper 2, question 8 on the vector scalar product. U and V are defined as V's vectors, find U dot V. Start of the exam paper tells you what U dot V is. You times each element and you add. So U dot V is equal to minus 1 times minus 7 plus 4 times 8 plus minus 3 times 5. That gives us 7 plus 32 minus 15. 7 plus 32 is 39. 39 minus 15 is 24. Okay, part B. Find the acute angle between U and V. So again, the start exam paper, A dot B is equal to the size of A plus the size of B times the cos of theta. So we know the size of, we know the A dot B, so we need to find the size of U and V. So the size of U is equal to the square root of minus 1 squared plus 4 squared plus minus 3 squared. Minus 1 squared plus 4 squared plus minus 3 squared. That's the square root of 1 plus 16 plus 9. That is 26. And then the size of V is equal to the square root of minus 7 squared plus 8 squared plus 5 squared. (49) plus 64 plus 25. Use the calculator anytime you want. That's 138. So that means that U dot V is equal to, we know that's 24. So 24 equals square root of 26, square root of 138, cos theta. So rearranging for cos theta, that means that cos theta is 24 over the square root of 26 times the square root of 138. So our theta is the inverse cos of all that. So we just get a calculator and work it out. So the inverse cos, 24 over root 26 times root 138. That gives me an answer of 66.38. So theta equals 66.34 degrees. And we're done there.
SQA Higher Maths 2019, paper 2, question 14, magnitude and scale product of a vector. We've got two vectors u and v such that the size of u is 4, the size of v is 5, and u dot u plus v is 21. Find the size of the angle in between. So let's start off with, if we look at the start of exam paper, a dot b is size a, size b, times the cos of the angle in between them. So we're going to kind of use that fact. So we've got u dot u plus v, well we can expand that just by saying we've got u dot u plus u dot v. So u dot u is equal to the size of u times the size of u times the cos of theta. But what's the angle in between a vector and itself? Well, it's nothing, so it's the cos of nothing. Plus the size of u times the size of v times the cos of theta, because we don't know that angle, but that equals 21. Well, the cos of 0 is 1. So we've got the size of u times the size of u, 4 times 4, times the cos of 0 is 1, plus 4 times 5 times the cos of theta equals 21. So that gives me 16 plus 20 cos theta equals 21. 21 minus 16 is 5, so 20 cos theta is equal to 5. which means that cos theta is equal to 5 over 20 or a quarter. So then put into our calculator the inverse cos of a quarter. That's 75.5 degrees. And it is just the angle in between the two vectors is acute, so we don't need to do a cast diagram or anything like that. 75.5 degrees is our answer. So theta equals 75.5 degrees. And we're done there. This has been Clelland Maths. Hope you found this useful. It's went through every single topic, question by question by question, for the maths exams in 2025. Take care, stay safe, and goodbye.